talk about maybe one of the demos they worked on, homework, or questions about how certain things operate. Like if you got PaperSpace installed, I'm interested to hear how that went or didn't go. Anyone? What are your questions?
No, almost
okay.
there.
Oh, you're almost there. Cool. Okay. We will go through the PaperSpace install again during class. Like I'll just quickly run through the steps. So if you had issues, we can see if those steps help. If you are still not set up or you want to like have me walk through it with you, like maybe stay after class a little bit and I can help walk people through the exact install steps. The video I posted should be good for everybody, but just in case, I also know there were some issues like getting access to one of the machines, but that should all be cleared up now. I spoke to the PaperSpace support folks and they should be, everyone should have access to that P5000. But I'll walk through it a little bit in class today.
Is there any way of like checking whether it went well, like some way to like check everything is fine or something, status or something?
Basically, if you have access to a machine, it went well. The install scripts, we can look at those. Basically, like for the rest of class, like as you build stuff, using those install scripts, if you're in issues, like it's likely something that I did, and I can help debug those. But yeah, in general, like I'm like part of this class is I'm here to help. So like some things are easier to do in person, like PaperSpace. If you get error messages when you're running certain commands or whatever, like those are things that I generally can help with over Slack or over email. So if you do get error messages when actually trying to run a command on the command line or in your PaperSpace machine, just Slack me with what the command is and I can get back to you pretty quickly and help fix those things. Does anyone want to talk about what some things they made in class? Joshy, you made some stuff, right?
Yeah, made some.
What'd you make?
Made some edges of waves and clouds.
Cool.
Originally, I was trying to chain a few things together, and I think we can talk about this later, but I found like there were very few models that kind of worked with each other on Runway. And I mean, I think I'm interested in where these models are kind of coming from and like maybe how we could add to the library, because it just seems like there's only like 20 or 30 of these models to kind of choose from. But
yeah, so with Runway there are some documents about how to use their API to build stuff.
Awesome. I
found it can be a little frustrating sometimes because it requires specific formats.
Sure.
And actually testing is kind of hard, but I can definitely share some of those things.
Cool.
I think chaining materials together is also kind of hard.
Yeah.
One of the things we'll definitely talk about today are like the most important things to learn about each of these machine learning models is what are their inputs and what are their outputs. Once you learn that, you can start to understand how to chain things together, but until you understand those, it's really hard. You almost feel like you're in a black box. So I know, Ryan, you had some issues with like understanding the grid view, right?
Yeah.
Okay, cool.
Yeah.
So maybe what I can do is let me just pull up Runway real quick and we can look at one of these. What model were you looking at?
Oh, yeah.
Yeah, I too had trouble with it.
Okay, awesome, cool. So let me explain a little bit about that. What model were you using? Do you remember?
If you just like scroll down, it was like one of the first couple ones, but it was like go down more. Oh, it's that one, Jed, on the left.
This one?
Yeah.
Big ByGAN. So yes, so this one is.
Well, actually, I used that to success.
Okay,
but then
cool.
the ones that I had trouble with were like the more simpler ones. That was like basically like generate kit self-portrait. I was just like,
okay.
I don't know what I'm supposed to do.
Yeah, so let me just grab one of these. Why don't we do Simpsons? When you get one of these running, there's an import source of vector, right? And what vector is a big grid, and we'll talk about this a lot more today, especially when we talk about StyleGAN's output. So StyleGAN's output, I'll jump ahead a little bit. StyleGAN's output is a 512-dimensional vector, which might not make sense to anyone. It generally like is confusing. So if you're coming from like the design world or just like graphics world, vector, you think about vector as like a clean line, right? So in math, what vector is vectors are points. They're points in space. So in the case of like your vector like Illustrator library, what it really means is like it's a series of points that creates curves or lines, right? So this is a vector, and if you know about Bezier lines, you know that there's like these handles. So when illustrators talk about vectors, they're actually talking about this, which is like a number of points in space that generate curves and other things. In math, all we mean by a vector is like essentially a coordinate system. So in the case of like 2D graphics, that means X and Y. In the case of runway, or in the case of StyleGAN, that means 512 of these coordinates. And we can't really, like, our brains don't work past 3 dimensions. So you just have to sort of think about it. If you've ever worked in JavaScript or anything, it's an array. So it's an array of 512 numbers that go from -1 to 1. And essentially what you're looking at in this grid view is you're looking at like, it starts with like a single point. So it starts with the center point. And what it's kind of doing is it's assuming, it's generating a bunch of what we would call noise, which is like random numbers between -1 and 1, and adding that to this point. So this is really, like, this can be like the hardest thing to understand about StyleGAN. But essentially, if you map it down to 2 dimensions, what you get are, like, there are, at any point in the space, what we call a latent space, is an image. So at this point, this is referencing 512 dimensions. And what that actually represents is an image. So when you have a point that is very nearby, the images look similar. When you have a point that's really far away, the images look very different. So what this is essentially like a runway tool to try to map, not really this space, but just to try to understand how things are close or not close to each other, right? So you can see that, like, this image and this image are pretty close to each other. And what that means is if you actually were to look at the dimensional space, they're probably pretty similar in terms of numbers. One thing that we will maybe look at in this class is you can actually download the vector from this. So if you click on one of these images, and then you come over here and you hit Save Vector, and then you click on this really quickly, this is going to give you, so it's a JSON file, so it's basically JavaScript, but it is this, what is like view word wrap. Yeah, so this is essentially how StyleGAN represents that image. Now this is not pixels, this is a mapping of space to what we call features, which I talked a little bit about last week. So basically, the model that you're going to build or train is the language that converts this vector into an image. So like that's the, sorry, yeah, it looks like you had a question.
No, nothing. So wait,
Yeah.
each of these values is like an arbitrarily defined feature, right? So it's like
Yes.
yellowness or spikiness, or in the case of Simpsons.
Potentially, yes, yeah,
Right, and then
yeah.
it goes from -1 to 1.
So this would have like 1024 values?
No, so this is just 512 values. It's always 512 values, and then depending on the size of the image, there is a model that maps this value to what that means in terms of pixel space. And like, it gets, like, how that actually maps is pretty complicated. But essentially, like, this is all, and like, remember, like, I think I talked about this last week, like, all these models are turning any value that you're inputting into it into a number. And that number in this case is this dimension, or this dimensional.
Represent -1 and 1.
-1 and 1 is just a way to map it, right? So like, realistically, it could mean any number of things. Like the actual space, if you were to, again, like flatten this down 2D, if you have a bunch of images that are really, really similar, it might actually all be like this area, and there's nothing over here. And all it's doing is sort of like easily mapping that to like the closest space it can. This is a super complicated topic, and I don't expect anyone to understand this immediately. But like, if you think about this, and then you think about this, it'll help explain a lot of how StyleGAN works. So when we make a video using StyleGAN, literally all we're doing is we are picking points at each space, and it's generating frames of a video. So in the case of some of the stuff that you'll see up here, which is like looping video, all it's doing is it's sort of like doing like a meandering loop. So it starts somewhere and then comes back around. And all it's saying is that at each one of these points, I want a new image. And because these images are like, or these points are really nearby each other, it's generating an interpolation.
Can you control the trajectory of the way it's going?
Sort of. I mean, yes, you can. But remember, at 512 dimensions, doing a perfect circle in just 2 dimensions will give you like a really similar image. Like it'll barely look like it animates. So we end up doing is we just inject a ton of noise into this, and there's ways to do looping noise. So basically you get this like very like sort of like chaotic movement through the space. And what we think about is, the way we think about animating this is like, we think about, if you imagine this being a circle, we think about, it's like math again, so, right? So it's radius. We think about how wide or how narrow are we going. So an image that basically does this, or like a video that does this, is going to be, remember, these are all close to each other, so this is going to be like a very subtle animation. Whereas something that goes through this, through the entire space, is going to be chaotic and give you a ton of different images, right? So what you can do in Runway is you can explore this space, but you can't actually animate stuff in Runway. So this is just a way of like, you can sort of see different values. And you'll see over here there's a thing called sampling distance. So sampling distance says, in this grid view, like how far away should each of these images be? So you could crank this down to really small and you would get like really subtle differentiations in your images. Let's let this run and see if it works.
What is doing now?
Oh, it did turn off. Oh, that's interesting. Okay, so that's we'll reset it. Sorry, what was your question?
No. I
Okay,
was
cool.
asking about
Yeah. It seems like Runway has recently added like some auto turning off features, so you don't get charged hundreds of dollars, which is helpful. But then, yes, it is very easy to lose money that way. But yeah, so like I generally use Runway as a way to explore these models, but I'm not necessarily doing a lot of my work in Runway because of the cost factor and because it's very easy to lose a lot of money if you aren't paying attention. PaperSpace has the same problem. If your machine is on, you're being charged. Make sure you turn it off when you're done. And we'll talk a little bit about that today as well, and I'll make sure that everyone is like aware of those issues. So here you can see, like with sampling distance, you'll see that all these images, like I am not even sure I could actually tell like how different these are because of this small sampling distance size. Whereas if I crank this up, like now we've got like some really big variations.
So would you say that the point of this is like there's no input from my end? You are just allowed to kind of like.
Yeah, it's more of an exploration tool. Yeah,
Okay.
exactly. Yeah.
How do you know, like you were saying that if you have a very narrowly grouped set of images, there might be sort of one fertile space in your model, and
Yeah.
you could just, how do you know if you're just missing whether there's like.
So we'll talk about it today. That gets into this thing actually. I started talking about last week, which is diversity. The diversity of your image sets matters a lot. And I think you had a question too of like, these just look like buildings that already exist. And part of when you play with someone else's model is you have to, so this goes back to that demo we did, which was like turning text into image, which is like, you have to know what they trained it on, right? So part of it is like in a case of that architecture thing, if they only trained it on like 50 images of buildings, it's a very narrow set of images, and it will very likely do a thing what we call overfitting, which is basically it'll memorize the images. And I'll talk about that next week when I do more on StyleGAN. But overfitting is really common, and the way to combat it is basically to have a bigger image set. So that's why I generally say like for something like StyleGAN, you want about 1,000 images, and you want those images to be somewhat like diverse. But finding that sweet spot is kind of that's the trick in like sort of learning how to do this stuff. So you can see with the bigger sampling distance, you have a lot more images. But what they do try to do is like they try to keep it so that if you're in a region, it's like generally like close to each other, right? So you can see these images are somewhat related compared to like further away. They're getting a little bit more different. So this is like this is a tool that they have. Like you won't find anyone else that has a tool like this for StyleGAN. So if you want to explore your own images, there's a couple ways you can do it. You can upload your own models to Runway. The process for that is kind of annoying, but you can do it. The other way is just, which I'll show next week when I do StyleGAN, is you can generate 1,000 images and you can sort of look and see which of them you like, and then you can use that in your next animation or process. So like if you know you want an image that is here, and you also know you want an image here, and you just want to interpolate between these two, like that's fairly easy to do within the process that I'll show you next week.
In Runway or?
I would probably recommend doing this in Colab or on your own machine, just because like it's very easy to do this. Like it's like a one-line command to do this. Whereas Runway is great. So like you can also download these images like very easily, which again maybe you just want prints and this is the way to do it. The other thing you can do is this has a lot of WebSocket stuff, which means you can talk to another browser window. So what a lot of people will do is they'll load up like P5.js, and you can actually interpolate. You can move through this space using JavaScript. So again, remember it's just a 512 dimensional vector. That just means it's a 512 dimensional array, which means you can animate that in various ways. So that's generally what people will do with Runway is they'll hook it up to another like API and like call it and change things that way.
So in your opinion, how many images do you think that this person uploaded to create this model?
I don't know, to be
Hard to
honest.
say.
I couldn't say. I would guess at least 1,000. It looks like it's pretty good. So you can actually do your own training in Runway. They have a training feature. The problem with it is that it's currently StyleGAN 1 instead of StyleGAN 2. So if you really like messy images like this, it might be good to try it. I think they do the first training in their system is free. So you can do a single training and just sort of see how it works. But until they get to StyleGAN 2, I don't really recommend using it because it's not as good in StyleGAN 1. But it is free. It's also the first version is free. It's pretty fast. So in like a couple hours, you can have like a good data set trained. Whereas our other process will be a little bit slower, but it is pretty expensive. Like it'll cost you $40, $50 to do a training on their system, which is no different than what it costs us. But it's StyleGAN 1, and it's like, so just like it compounds. So it's sort of up to you. I do find that some people like using Runway because it's more GUI, right? There's no terminal, there's no command line, there's like no other things. So some people will like using Runway more. And I know that they're working on adding StyleGAN 2. They just added text-based training as well. So if you ever seen like a text generator, like you can do stuff like that. So if you're into poetry or other things, like you can try playing with that in there. So like Runway is a really good tool if you just want to like play around and explore. I find when you want to do specific things, it can be a little bit harder.
Can you do the next frame prediction?
You cannot do next frame prediction. So I think this is what Joshua was getting at, which is like, it also has a very limited set of models, right? So they only released the StyleGAN training about 4 or 5 months ago, maybe even less. And now there's like an explosion of StyleGAN models in here. But if you don't want a StyleGAN model, you're pretty limited. Like there are like 20 to 30 models you can play with.
They should cut creators in. Like if you're making good models, they should give you a cent or two on that.
They're struggling to make money. I mean, I'm
sure,
guessing they're struggling to make money
sure.
too. So yes. Yeah, I mean, they actually work out of the PaperSpace studios. They're over in Bushwick. So like,
not affiliated.
they are not affiliated, although my guess is they're using some PaperSpace tools to actually manage backend. The people who started Runway actually came out of ITP a couple years ago. So this was like part of their thesis project at ITP, and they've now sort of like turned it into a business and are a startup raising money and doing all sorts of startup-y things. Any other questions about models or anything?
What does truncation do?
Oh yeah, so truncation is this other thing that is like outside of the space. Truncation essentially is like a special tool within StyleGAN to say how realistic do I want this image to be. And so if you're at 0.5 truncation, it's generally like pretty close to the data set you trained it on in terms of realism. If you're at 1.0 or further, it's like gets weirder. So at 0.7, you'll see like you see faces. Actually, let's just run it again and we can do this. All right, this is at 0.8, right? So at 0.8, you can see the faces, but it's still pretty weird. If I turn this down to 0.45 or whatever, those look more face-like, right? And if I crank it up to, okay, it only goes up to 1. You can actually, like, outside Runway, you can crank it up even further, and you'll get really, really weird images.
Is this another axis?
It's not an axis. It's like a mathematic property. Like, if you actually get into how StyleGAN is built, like, the mathematic model is pretty insane behind it. But it's basically another function that, like, sort of the way I describe it is like at the very edges of a model, you're gonna get like really weird images, right? Mm-hmm. So you could think of truncation as like what is the actual space that I'm working out of. That's not really how it works, but that's like you could make that analogy and it would make sense like that. Yeah, so you can see like these are really weird, right? Like so this one especially is getting like really warped and that sort of thing, and this one has 3 eyes. So like again, depending on what you want to produce, like you might find like making the truncation value really high makes sense.
And then a follow-up question to that: in Runway or out of Runway, when you generate this field of images, or is there a way to batch download everything? or?
Yes. So there definitely is outside of Runway in something like Collab or in something like PaperSpace.
Okay.
In Runway, it's actually like what you do is you actually do. You hit this export button, and then what you can do is you can actually hit switches to image directory, and then you hit export, and literally all you do is you just click around, and that just starts. That's just gonna start downloading all of those images that you click
So you have
on.
to individually click each one you want?
Yeah. So there's no like batch export in this feature.
But like if you were in terminal, you could figure out
Yeah.
a way to do it?
Yeah, internally you can in P5.js, like what you'll do is you actually like it just downloads as each frame is built, and it downloads it to whatever folder you give it. Outside of Runway, you can definitely do some batch downloading, and like one good way is like so I usually use an FTP client. So this happens to be like one of actually let me just see if I have any generated images over here. I might have cleaned up my hard drive, or might have cleaned up my drive, and there might not be stuff in here. But in, yeah, these are empty. But in Terminal, we'll talk about this next week, but you can basically generate a ton of images,
Yeah.
and you just zip them up and you download them that way.
Awesome.
Yeah.
I had a question about another model
Yeah.
that I was looking at. Yeah, it's in the browse. It's the second one, first order motion model for image analysis.
Yeah, so this is a brand new one, and I
Okay.
honestly don't really know exactly how it works.
Okay.
But let's see. I know what it's supposed to do.
But I think when I was reading the description, it was like you want to basically have the source image be like
Oh.
like a photo, and then the driving image be like whatever has motion in it.
Yep, so
And
let's...
Yeah, if you have like a video or like a still, but then it didn't produce anything, so I don't know if I did it wrong.
I don't know if so basically like okay, so actually let me where did I see this? I think I saw it on Instagram. If you go to Runway's Instagram account. This is like the new hot model that people are working on this week. So this is
Yeah.
Yes.
Just for making fake news.
pretty much, yeah. But basically what this can do is it can pick up your features and then it can map it to a bunch of other objects. So I think what you're looking at, or what this is meant to be here, is what's the driving image? So that would be motion or a video. And then what do you want the source to be? So my guess is that how Andreas did this is it's actually a couple different, it's like he did this, he probably recorded this video and then ran it once with each image, with each source image. So then he was able to make this sort of manipulation.
Okay. It just like didn't work for me, but
It might mean that what you need is the exact right image, which like means I don't know if I have any faces in here. But basically you would want to find a face
yeah.
and you want your face and you want them to match up like really pretty closely.
Yeah.
Because if they're off even slightly, like if you're turned like this way, but the face is projected straight forward, like it might not match up correctly. So like a lot of this stuff is like you have to find out exactly how to match it up, and then you've got to record it the right way or that sort of thing. Yeah, it can be a little tricky, but this is definitely one of the new models. So like
Okay.
basically what happens is someone releases a model like once a month that people go apeshit over, and they will like play with it for like a week, and then everyone forgets about it, and then like yeah, it's like very very unlikely that like most models survive past that week of like this is the cool new fart app.
Yeah.
So yeah, like basically the models I teach in this class are the ones that have made it past that like fart app sort of experience. Sorry, you're just taking a sip right there. Cool. Any other questions about Runway?
Can you see the databases that the models were trained on?
Most of the time, no.
Okay.
There are places in training. If you train a new model, they do have a number of data sets that they make available to you.
Okay.
So like mountains, airplanes, graffiti, forests, skyscrapers.
It's all like front of the new sketchbook kind of stuff.
Yeah, and they used to even let you download these, but I don't think they do anymore. But yeah, so like that's the issue with like Runway is you don't know what they were trained on.
Yeah.
So it can be a little tricky to figure out like, is this thing overfitting? Is it actually good? Like, we'll talk about this next week because there are ways to sort of see if the model's overfitting, or what we also call mode collapse. But we'll talk about that more next week. Cool. So let's get started with class. 30 minutes in, we can make it, I think. We'll see. Okay, so just a reminder, last week we did some inspiration stuff. I hope everyone got some good ideas or maybe some inspiration for things they might want to make. This week we're going to do some install stuff. I'm mostly going to focus on datasets. That's like the hardest part of this class, or like you will find it's the most time-consuming part of this class. So we'll sort of talk about how to make a dataset, how to figure out a dataset per what you're trying to make, like those sort of things. And then for the next couple weeks, we'll do some, this is wrong, is StyleGAN next week, and then style transfer next term prediction the week after. And then the last week will sort of be an open class period where people can either demo things they've made, or I'll come around and just sort of help people with their projects. We'll just sort of see where we go. Okay, so this class we're going to do some PaperSpace demo, we're going to do a terminal demo, and then we're mostly going to talk about datasets and models overview. And I might get to a dataset tools demo. If not, I will record a good dataset tools demo, and then I'll share with everyone.
Is that like scrapers and stuff?
Those scrapers, I also have written some custom software to allow you to do croppings and other things. So basically, if you scrape a bunch of images, like in the case of StyleGAN, let's say you have 1,000 images, and you want to make them all square. You don't want to open them all up in Photoshop one by one and do that work. It's going to be really annoying. So I've written some tools that can do a bunch of different features, types of things for you.
Any resolution?
Any resolution, yeah. Okay, grab a drink real quick. Lose my voice already. So PaperSpace. So I know most of you have at least set up an account with it. We'll get you signed up and set up a server for you today. The reason we need to use PaperSpace, for those of you that don't know, is the biggest thing that we need is we need an NVIDIA GPU. I won't get into the exact requirements for why we need GPUs, but basically GPUs can perform math a lot better than we can, or also a lot better than our normal computers can. The reason you need an NVIDIA GPU is NVIDIA has sort of cornered the market and built a bunch of libraries for us to do this work. So pretty much anyone that does image making using machine learning uses an NVIDIA GPU. They also use Linux, which I assume none of you have, which is why we also need to have a PaperSpace account. The other thing is that doing any of this work, even if you had your own Linux machine, it'll basically lock up your computer. So you couldn't use it for a couple days while you're training it. So we use a rented server as a way to get access to that, lock up that server, only do work on that. It keeps it cleaner, it keeps it running really efficiently, and then we can download it from there. The reason I teach with PaperSpace is they have a built-in machine learning template which already has installed a ton of the software we need. It's just way easier. If you use AWS or other things, you can, but you have to learn all the stuff you have to install, and it's a headache, especially for a short class like this. It's affordable-ish. I will acknowledge is not the cheapest option. There are cheaper options out there. Most of them do not come with the software you need. So you'll find a cheaper option, but unless you've installed software before on a server yourself, I don't really recommend it. So it is 78 cents a minute, or an hour, which means that the $100 you all got as credits will I think that's a couple days worth of training time. So in the case of StyleGAN, a high-res StyleGAN model, so 1024 by 1024, takes about 3 to 4 days to train. So just be aware of that. If you want to do that model, maybe don't run your server until you're ready to do that work. And I'll talk about some of the details of that thing. Otherwise, if you want to run a lower res model, you can generally run them a little bit quicker, maybe a day or two of training time. Yeah.
Is it common to train, to run a very low res to see if you like it or not, and then run it again as high res?
It probably doesn't matter. The truth is that, and we'll talk about this next week, but the truth is that there's pitfalls with both of those. In part because there's just some randomness in all these models.
So it's not going to be identical?
It's never going to be identical, yeah. One thing you can do is if you want to just make something small, there's a machine learning, there are machine learning models called super resolution networks, and they actually upscale images better than Photoshop. I think I talked about this last week, but they make images bigger and better than Photoshop does, but they're still a little wonky. So actually the first time I taught this class, we did trainings at 512 by 512, and then we could use super resolution to make them bigger. There's downsides to each of those. For this class, I generally teach 1024 by 1024, in part because there's some new techniques that can make that run a little bit faster. So we'll look at that. So important to know is that you're charged by the hour on your PaperSpace machines. And I think I talked about in the video how to turn it on and off. but make sure your machine is off if you're not using it. Like runway or like other things, if your machine is on, it will just be charging you money, and if you don't use it for a week and you come back, you'll have found that it charged you $150. And you can't get that money back. It just like is what it is. There's an auto shut-off feature in PaperSpace where you can set it to turn off immediately after 24 hours. The downside to that is if you set that and then you start training StyleGAN, it's going to turn off early. There are ways to restart it, other like ways around it, but it's just like you have to sort of keep an eye on it. It's the one like really annoying part of this process is just like kind of have to like babysit your machine to make sure it's still running, make sure you're not being overcharged, that sort of thing. What's also really nice about PaperSpace is it has a really good uptime. Uptime just means that it like your server stays connected. If you use other servers that are like cheaper but hackier, your machine might turn off or turn on. And for something like StyleGAN where you're training for a couple days, if it turns off in the middle of it and you don't know about it, that sucks. So it's just a nice way. I always say this: the UI is simple for PaperSpace, and some people are like it sucks, and some people really like it. It's easier than AWS, so like it's still better. But yes, some people don't like the interface, and that just is what it is. So long as you like, you'll learn over a couple days just like where to turn things on and off and that sort of thing. Okay, so I'll just quickly show you how to like do this. I'll just like log into PaperSpace and show you how the process to go about this. Important things to know is I think in that demo video I had you create a team and I had you invite me to that team. That gives me some admin access, so in case you have issues, I can like log into your account and make sure things are running right. Make sure you add your promo code before you set up your machine. You do have to give it a credit card, and I highly recommend that if you, after this class, you're like, I never want to touch this shit again, that you delete your PaperSpace account, because there are weird bugs where you might still be getting charged for things. The thing you'll want to do is you want to make sure you if you know you're not going to use your machine for like a month, make sure you destroy it. I can show you how to do that really quickly as well. Destroying a machine means they will stop charging you. That's the hope. I had one student recently who told me that like for whatever reason it didn't work, and I had to reach out to support, and like they had to delete their account, other stuff. So like anything, keep an eye on your credit card account. Make sure you're not being double charged for things. Just caveat. And then there's software to install, which I think I did in the demo video. I probably won't show that part, but let me know if you have issues with installing that stuff. Really quickly, I'm just going to log into my PaperSpace account and show you a couple little things. I'm just going to go PaperSpace, sign in. So the way to create a machine is you're going to come over here to core, you're going to go to machines, and you're going to say new machine. For everyone here, just pick US East. I explain a little bit how this works, but like, and if you're in this class, just use US East. You'll want to come over here to public templates, and you'll want to click the ML in a box. This just installs a bunch of machine learning software you're going to need. The next thing that you want is you want to choose the P5000. I don't recommend any of the other machines just because this one's pretty expensive, and this thing works just for everything that we're teaching in this class. So just choose P5000. Storage, I recommend either 100 gigabytes or 250 gigabytes, especially if you're going to do next stream prediction. If you know you want to do some next stream prediction stuff, choose 250 because those models are huge. Yes?
Oh, sorry. So if my promo code isn't working, that's like not gonna work right now.
Not right now, but
Okay.
we'll wait. We'll figure out your promo code situation after class for sure. Because I definitely want you to get your money's worth for everything. So we'll make sure we get it figured out. But yeah, I would say don't set up your server until we have that working for you. So you'll set like whatever size storage you want. It's important to know that this is charged by the month. So no matter what, if you leave your machine, like even if your machine's off, you're gonna get charged a monthly fee for this for the basic storage. So if you know like after this class you're done, make sure you destroy your machine afterward. I'll show you how to do that in a minute, but make sure you like destroy it. Otherwise you will get monthly charges. You don't need to worry about any of these other things. I generally turn off auto snapshot, but I do turn on public IP. Public IP is really important. You need that to be able to SSH into your box. I'll talk a little bit of SSHing, or to be able to access it via FTP. So make sure that's on. You'll need to add payment stuff. I'm not going to actually go ahead and create this because I already have like 5 servers through these folks. But once you add a card, then you can actually create your account. When you make a machine, it will immediately turn on your machine. So the thing is, if you like just made an account today and you didn't turn off your machine, check now and make sure you turn it off. Because as it starts, it will it'll like install some software. Then it'll start your machine. So make sure you turn it off at that point.
Sorry, what was the amount of storage that you recommend?
100 or 250. It's sort of up to you. I would say if you know you want to play around with some next room protection, definitely do 250.
Cool.
Yep. Okay, so if you once you've actually made a machine, inside of core, you'll see here there's machines. Most of you should only have one machine. I have 5 because this is just how my life is some days. The way to turn on a machine, there's 2 things you can do. One is you can either click right here. This is going to launch a desktop version. And like the desktop version's fine, but it's not my favorite way to access it. What I recommend doing is clicking the little gear icon here. You click this guy. They just recently changed how this is laid out, but basically you've got start, you've got restart. And I don't know where they had destroy at this point, but we'll figure that out. So to start your machine, you just come over here and you click start. You're going to see this is now changing and it's running. The important thing that you want is you want this public IP address. So you're going to copy this. This is how you're going to be able to access your machine via FTP or via SSH. This will tell you it's on and it's ready. It takes another 3 or 4 minutes for it actually to be on and ready. So give it a minute. Sometimes what happens is people will like turn on as soon as they see the on button, they like go and they log in. They're like, I can't log in. It always takes a couple more minutes than it says it does. Once you have a login here, there's 2 ways you can access your machine. I'll show SSH in a minute. The other way is you can open the desktop. If you're like a little bit afraid of using terminal, maybe start with the desktop because it's a little bit more like clear what you're actually doing. But I also think this is a great class to learn a little bit of terminal. So like dig in and try it. This is now connecting. Sometimes this connection takes a while. In the meantime, let me show you how to SSH in. So if you've never used terminal before, we'll talk a little bit about terminal in a little bit. But basically, the way to access your machine, I'll make this a little bit bigger. So SSH is basically a command to log into a remote machine. The way you do it is you type SSH, and then you need to type the username, and then your public IP address. Now for PaperSpace, the username is always PaperSpace. So it's always going to be PaperSpace @ and then whatever your public IP address is. So you'll come back here. You'll if you hover over public IP, you'll see there's a little copy icon. You'll copy it. You'll paste it here. When you hit return, it's going to ask you for a password. Now, if you just made a PaperSpace machine, PaperSpace will email you a password. It's an auto-generated password. You can use it. It's fine. If you want to change your password, I can show you how to do that after class. But generally, like you'll need to give it a password. I can log in and grab mine really quickly. This was this one. The other thing to know, and this always catches people, is when you type something in a password, nothing shows. That's a security feature. So if you type it by hand and you don't know if you typed the right command or missed a key, like you just have to hit enter and you'll have to redo it again. But nothing will show here. So like that really confuses people the first time. So even if you do copy and paste, it'll never show anything. So now I'm logged in. When you first hit okay, the other thing to know about terminal, I'll probably show a bunch of these commands. If you ever have questions about what I'm doing, I'll let you know. Just ask. ls says like show me what's in this folder. So servers are just like your desktop machine. They have a series of folders. They have a series of files. That's all it is. When you hit ls, it's going to tell you, okay, here are all the files that I have in this location. This is your home folder. If you're a Mac person, it's the same as what your name is when you log in. These are all the files in this server, in this machine, essentially. Many of you will probably not see all of these unless you've gone through and installed the scripts that I told you to. But what you can see is you'll see desktop, downloads, documents, music, pictures, videos. So this is also if you've ever started a brand new Mac, these are like the exact same file folders. Basically, all you're looking at is a computer that you are remotely connecting into. That's all this is. There's just a Linux machine. So if we go back to, let's see if this works. This is the desktop view. And if you actually look in here and you look inside of your files system here, you'll see that it is the exact same files and folders that you saw when you hit ls. So all you're doing is it's two different views of how to access this file. Some of you might prefer using this method. It's got some tricks and little weird issues of it, but you can use it. One thing is copy and paste between your main computer and this view doesn't work. So you're gonna have to type out all your commands by hand, which sucks, but you can do it. Also, if you are like not comfortable using FTP or other things, a nice way is you can just use the Firefox command within here. So say that you want to save a bunch of your files, what you should do is have a Dropbox or Drive account, log into those Dropbox or Drive accounts through Firefox here, and then just drag your folders like you would through your own desktop. So you can get away with just using this GUI. I generally don't teach it because it's like a little bit frustrating. I have to remember all the commands to type out by hand, that sort of thing. You can do it, however. Most of the stuff that I will show in this class will be through the terminal. So the other thing that I mentioned that you should do is you should install software. It is this thing. If you've never used GitHub before, this might be a little weird as well. All the instructions are here, but essentially what you need to do is you need to copy this URL, type git clone, and then paste this URL. You'll hit enter. It'll install some stuff. This is already installed here, so you can see at the end here is AI. So it's already installed. What you need to do then is cd, which says change directory. So that's like, what folder do I want to move to? So if I do cd AI, and then I look inside this folder, you'll see there's a bunch of commands in here. What you will run is you'll actually run this command. It hasn't changed anything from my last class. So what you'll do is you'll type bash rc, and if you hit tab when you've started a command, it'll try to autofill what that file is. That's a nice little like shorthand instead of having to type out the entire thing. You'll hit enter and it'll install all these other files. So it'll install dataset tools, style TF. It'll install all this stuff for you. I already have installed it here, so I won't run it. But when you run this, if you see errors, or you like after you've run this, if you so what you also can do is cd .. which means go back a folder. So when you do that, if you then after you've run that command, if you're not seeing any folders here that look new, that means something went wrong, which means just let me know and we can figure out how to work on it together. Cool. That also is kind of our terminal demo for the day. I recognize that's throwing a lot of people like immediately. There are some resources here about a little bit more about how to like use the terminal and stuff. And if you are new to terminal and you really like want to understand it more, like let me know and I can send you more resources. You will find this frustrating. I promise you will. It's okay. Try it for a little bit, and if it just doesn't work for you, go back to the desktop. But I do find this is faster. You can do more with it. It's pretty easily Googleable. Like you can Google like, how do I do this in the command line, and you'll find some responses. A lot of people look at this command line and they're like, shit, I'm gonna break something. Most of the time you can't break much, or like we can fix it. Like there is a fear that like you can destroy your computer, and you could, but like I'm not going to tell you how to do that, and you would have to Google how to do that to actually be able to do it. So it will be a little uncomfortable at first, but like I promise if you just like sit there and try, and the way that I'm going to teach it is I'm going to give you the commands to use. So really all you have to do is copy and paste and change a couple things. And like I am aware that like for most of you it'll probably be new, but I'll try to help in class or like DM me over Slack and we can try to figure stuff out together. Okay, I ran through that really quickly, I'm aware. I just want to make sure that I talk more about datasets, which is like an important thing. So if there's anything you're stuck on and you haven't gotten to do, oh, actually, let me talk about one more thing with PaperSpace. Now that I've got that machine running, let me show you how to stop it. When it is on and ready, there's a button over here called shutdown. Make sure you hit shutdown when you're done with it. So like I'm done with this demo, like I'm gonna hit shutdown. Make sure that this spins all the way until it says off and your button turns gray.
Closing out of the web browser doesn't shut it down. It'll keep running even if the browser window is closed.
Yes.
Okay.
That is a benefit of using a server, is that it stays running when you're even not using it. But you do need to make sure you turn it off.
They moved the deactivation button next to machine type.
They did, yes. I just noticed that too. So the way to destroy your machine is if you never want to use it again, you will click this deactivate button. This isn't off yet, so you basically have to wait until it's completely off for you to click this deactivate button. When you click this, I think you'll get a modal that'll say, are you sure? I'm not going to click it just in case it does actually delete my machine. But But yes, this is what you want to hit. Once you've deleted it, you'll no longer be charged monthly fees. You will also lose everything on the machine. Like it doesn't save anything. So before you hit deactivate, make sure you save the files you want out of it. Because once you hit deactivate, it's gone. So that's just a really important thing to remember. This is being really slow to shut it off. I'll deal with it later. I don't care if they charge me 75 cents for the rest of class. I just want to jump to Datasets real quick. Are there any like immediate questions? You're always welcome to DM me, or like we can talk after class and like I can try to help people a little bit more. But any like immediate, like I have to have this answered now questions. Sorry, I know I'm rushing through this week. I know this week is like the hardest week for me, or like the most intensive week. So I want to make sure I get through everything.
This is also all recorded, right?
Most of this is recorded. If you have other questions that are not covered in that recording, let me know. Okay, I'm going to jump through Datasets because I want to get through this really quickly because I think this is like the most important part of this particular week of class. Okay, so I probably have said this last week, but like Datasets are the most creative part of what we're going to do in this class. Everything you're going to do is based on the data set you're using, right? So with most of these models, like there are pre-trained models and you could just use those and like you could make faces or whatever out of those models. But this class is to make you have your own data set, do your own training, and generate your own images out of it. So everything in this class is going to be really centered around making a data set. And I'll talk about like what you want to make for each model, like those sort of things. But I just want to quickly run through how a data set works. Okay, so let's assume that you have a robot and you want the robot to make music. How would you go about doing this? So you have to find a data set, right? And what would a data set of music potentially be? So it could be sound, or maybe in the case of, or okay, let's say you want to train the robot to make country music, and you want to have it make metal music. The way you do that is through, one way you could do it through sound. That's like a pretty hard way to do it actually. Or you could do it through something like training it on sheet music. So maybe what I want to do to have this robot be able to play music is I want to find a lot of sheet music. Maybe find 1,000 examples of country music done through sheet music, 1,000 examples of metal done through sheet music. There's a lot of other parts missing in sheet music, but like let's just assume for that it works. Okay, so this is the data, right? So we have to collect all this corpus of data. You might hear me call it a corpus. That just means a big collection of data. In this case, I just have to go find sheet music, right? And there are sites where I can go download a bunch of sheet music, or there are other ways I can find sort of that data. Okay, so I've trained this guy to make music using a guitar, but what if I try to throw like Bach at it, right? And that's like a symphony, right? So that is different than guitar music. Well, guess what? Because I trained it on playing guitar, and now I'm trying to throw a different piece of data at it, it doesn't connect. So this is something that's really, really important, and this will be the most important part of using other people's models or understanding the models we're going to work with, is what is the input? Am I matching to the expected input, right? And when I get something out of it, is the output, what I feed it, is it expected to match what it has here, right? So in the case of this robot, I've trained it on guitar music, but now I'm trying to give it a symphony like violin or cello or something else, and it doesn't know how to actually interpret that. So last week, what I really wanted to focus on was like, machine learning models do one thing well, and you can help train it on what that one thing is, but they generally only do one thing well. So in this case, I trained a model to like play guitar well, and throwing other types of data at it didn't work. And that's like the key thing to sort of remember as like an analogy here. So it's the most creative part, it's also the hardest part, especially for producing images, right? So we talked about how for StyleGAN you need like at least 1,000 images, right? It's very easy for me to say like, I have a favorite painter and I can go download their images. The chances of a single painter having produced 1,000 paintings is pretty rare, right? So now it's like, okay, I have to hit 1,000 and I have to find like a painting of maybe a certain style or those sort of things. The hardest part of this is during like, how do I find the data and how do I like actually pull it down and how do I make it all similar? Okay, so in this class, we're going to look at a bunch of different models. So each of these on the left-hand side here is a model, and on the right-hand side is the type of data that it takes. So style transfer is pretty easy, right? You need two different images. You need a constant image and a style image. Next from prediction needs a video, right? So we take a video and we turn it into a bunch of different frames. That's fairly easy to grab too. Munit or CycleGAN needs about 250 images, but you need two different sets of images, right? So that's horses and zebras. So that's getting a little bit trickier, right? Like I could probably find 250 horse images or zebra images, but if there's something very specific I want, it's gonna be hard for me to find that data. Pix2Pix takes the same, but is like a little bit more. And then StyleGAN, we need 1,000 images. Like 1,000 images is actually hard to find. We want 1,000 different images, but they're somewhat related. Like that gets trickier. So again, remember that every model does one thing well, and it's important to know what that one thing is. So I'm going to quickly run through each model and just sort of remind you how they work. This is style transfer. It applies texture from one image to the content of another image. If you're interested, the GitHub repos that we're going to use in class are linked here. There's also, because this is like data science stuff, there's a paper for each one of these models. So if you want to understand what the scientist was trying to do with it, you can go read the paper. Okay, so the input for a style transfer is one content image and one or more style images. And the output of that is one image, right? So it combines those two together and you get one image out. So here's an example of a style transfer. This is actually sort of flipped. Like you can actually imagine these things on the right being the inputs. These things on the left is the output. So what we have here is we have a content image of a lion. We have a starry night. And when we combine them, we get this textured image of the content. So this is how style transfer works. I'll talk a little bit more about this in week 4, I think, about like the details and minutiae of this. But essentially, this is how it works: input and output. And you can do video with this. Literally, all it's doing is it's taking each frame of a video, and it's doing that input and output of that frame. So you feed it a video as the input of your content, and then you give it a style video or style image, and it generates individual frames of each of the videos, and you recombine it using like After Effects or other things.
Is it kind of like the model that was like poppin' these days or whatever that came out recently, and we had to put a video in that we were trying on Runway earlier?
It's a little bit like that, but not the same. Okay. The way the model actually works and tries to match things is probably more along the lines of like Pix2Pix, which it tries to figure out your skeletal system of your face.
Okay.
Takes that and applies that to these new images. Probably how it works. I actually haven't looked into how that one works, but style transfer tends to be like very unique in models because of the way that it is built, and we will definitely talk about that more in week 4.
So there's no training in style transfer?
There is no training. Yeah, correct. There is no training in style transfer, or there is a way of training in other versions, but the version we're going to look at is there's no training. The thing is, this process is slow, but it gives you really good results. The way you might train something is if you want something really fast, you have to do some training so that you can then get really fast outputs out of it. So that in case of like you want to do like a live interactive demo, you might do some training to actually like have it learn that model really well.
And how did you create that animation?
This animation, yeah, so it's literally like you take a video, you break it up into all the frames, and then you do individual style transfer on each of those frames. Then you bring that back into some like After Effects or FFmpeg, and you set them all up in a line, and you just generate a video out of that. So again, a video is just individual frames, and all we're doing is like we're separating them out, we're doing the style transfer, then we're bringing them back together. Okay, Pix2Pix. So again, this is like cat on the left, cat on the right. So what does Pix2Pix do? So it generalizes a correlation between two paired images. That's a fancy way of saying that it figures out how to translate one image to another. So this is not horses to zebras. We'll talk about horses to zebras next. But this is edges to cats, which is this. Or it is, let me skip ahead. This is another way to think about how you can do matches. So this is a house. This is what is called segmentation data. It's basically just like going into Photoshop and like outlining each of these shapes. And you do this across multiple houses, right? So the input is actually this. You're actually inputting both of these together. And what it's learning is learning what do I do where I see red? What do I see when I see yellow? And how do I convert that back and forth? So the training data. So it's also important, like style transfer doesn't have a training period. But for other models where there's a training period, you need to think about what the training inputs are. And then when you're testing it, you need to think about what the test input is. So I'll get to that in a minute, but the training data for this is 2 folders, or 2 images side by side. The first folder is what we call folder A. That is one type of image. And then your folder B is directly correlated to that next image. So again, On the left here we have a full, well, this would be A, and then on the right here would be B. So the A is the real photo, the B is the segmentation data. Now, when you want to actually get something out of it, what you need to do is either feed it an A or a B. And basically what you feed it is what you want out of it is the opposite, right? So in the case of testing, what most people will do is they will feed it a segment, right? You could draw an imaginary like shapes of these things, and it would spit out a real image, or a real image, a photographic image, let's say that, not a real image. You could also do the opposite, right? The way these models work is they learn the translation between the two, so that means they can go both directions. So you could feed it a new house and it would spit out what it believes to be the segmentation data of that. What's nice about this is like, the hardest part is getting your first set of data. Once you've got that, it's really easy to ping pong back and forth between different sets.
What makes like a correlated, data set and I know it's an abstract concept, but like
yeah, it's also like, what do you consider correlated, or what are you hoping the machine learns out of it?
Yeah.
A lot of times it means that like you could lay them over top of each other and you could see the representations between those two, right? So like if I were to shift this red down a little bit or shift this red up a little bit, it's gonna try to tell the machine is gonna try to like understand those mappings, and like what's the black box of machine learning is like, what is that actual mapping? We want to make it as clear as possible what you're trying to map it to. So in the case of edges to cats, what they did is they took photos of cats and they basically drew outlines. Actually draw outlines. There's like a model to get edges from, but basically they get the edges out of it, and then like the machine learns that like, oh, these are the edges of a cat. When I see something that is like, when I see something like that is this shape, right? Like I know that there should probably be rings on there because like I've seen a bunch of cats with rings. That's like pretty like. To actually do this mathematically is like, what the fuck? Like that's really crazy. But that's essentially what it does. So there's different ways in which you can do these model trainings. Let me see if I have other examples. So here's another good example. This is aerial images from Google Maps, and then they're color coded, right? So red is buildings, blue is water, and white is, I guess, rivers? I don't know, this looks like Venice, right? I don't know. Non-buildings, non-waters, yes. What you can then do once it's been trained is you can do the reverse, right? So now someone drew this thing and they get this like kind of crazy. Now it's important to remember like this doesn't really look like houses, but like that might be because of what it was trained on, right? So if you're trained on multiple different types of houses across the world, you're gonna get different types of looking like house things. If you were to take thousands of photos of whatever this city is, it would almost always generate red roofs, right? So again, this is where it matters what your inputs and what your training stuff on is. And you have to sort of think about like, what do I maybe want to get out of as the outputs? If I want somewhere it's always got red roof buildings, then I might want to pull all my data from buildings that look like this. Yeah.
Why wouldn't you just like make all the roofs the same color in your photo inputs, like in Photoshop or something?
What do you want the output to be? Do you always?
Well, if you always wanted your roofs to be red or gray.
The reason you want to do that is doing that for 1,000 images is gonna suck.
Well, this already looks like it kind of sucks, right?
Yeah.
Why would you stop there?
Pix to Pix is my least favorite model to work on because it is is very time intensive.
Gotcha. As far as mapping.
Doing this work this work sucks. Now there are models that can actually do the segmentation for you. So like there could be ways you could get to this. I also personally I find the results of this like so, right? Like this is cool, but like it doesn't interest me. Maybe it interests you guys. And I don't want to like, if you're really into this, like we can do it, but like I generally just find like it feels like a one-trick pony where like, cool, I've now drawn this, I don't know what I can do with it more. Maybe there are other things you could do, but it's just, this is super time intensive, and I generally find the payoff not worth it for what you get.
And there's no standard in how the other image should look like in terms of colors and stuff like that, right?
No, it's just based on what you train it on. So it's like, also like, the color codings don't matter.
It's just internal.
Yeah, it's totally internal. So like the other thing about these models, again, this model can only interpret these colors to these outputs, right? So if I were to start drawing pink in here, which you didn't learn, it's never gonna know like, how do I generate pink? or like if I all of a sudden want to say green is now, or like blue is now mountains, it's gonna be like I can't do that. I was never taught that. So again, it's really important to think about input and output. Yeah.
Are there any like examples of people using pix-to-pix where it's just like totally abstract, where it's just like the model is all images that aren't correlated, the colors are placed totally crazily, the objective is just makes an insane thing. Like,
This is always people's question. I'm always like, or like, no, because the cost of doing this work would suck, and the cost of training it, like, it just doesn't.
you want to make some arbitrary.
If you want to make some arbitrary shit, do it in Photoshop directly. Yeah, exactly.
And the second image always has to be like in like color blocking. That's the way they learn. It could be
No.
Was it Scott?
Do I have other examples? Yeah, so Scott Eaton's example. So it could be edges.
Yeah.
It could be, actually, let me just do this. So there, if you, or actually, let me go here. There's a reason I put this in here, which is if you go to this GitHub repo, and you go here to pix, and you look at the, so here's some examples. Pull this up a little bit.
right.
So again, so it could be grayscale. It could be whatever color segments you want. It could be black and white to color. It could be edges. It could be day to night.
Right.
So again, you just have to imagine that two images are overlaid over top of each other, and they have to somehow map to each other, one way or another. In the case of edges, it's just like the shape outside of it, and what it's trying to learn is how to fill it in. In the case of day to night, it's literally like, what are the color translations between those two scenes? Day to night's really hard, right? Because like you're not gonna very easily find data where like you have a photo of the exact same place in both day and night, right? This is probably like a highway cam or something.
So would this be good for like consistent photo filtering?
Yes. Yep. So like this is, I think I talked about this last week, but like this is how they do portrait mode in an iPhone, because they have basically what they do is they take very calculated photos where they will take a photo of something out of their iPhone, like straight raw, and then they will like literally have a camera that sits at the exact same plane and take a high res, like beautiful, like bokeh photo, and then they can map those two together. That's literally like, it's probably actually a little bit more complicated because it's Apple and they're probably doing some other things, but it's essentially that, like, it's essentially mapping a shitty camera photo to a good, like, high quality photo.
So if you were like doing like animation frame by frame, like with that handbag, you could like have it animate somewhere. The handbag could like grow and shrink and stuff if you were willing to go through.
They were doing that with the cats one.
Yeah.
The animators jumped to that cat, like picks the cats or whatever it was. They made some really fucked up shit.
So there's a little bit of a trick in that, which is that a lot of these models have built-in noise in them, like basically just a built-in randomness. So if you were to actually animate that, it would be a little flickery. It wouldn't necessarily feel like really smooth.
Gotcha.
There's ways to go around to fix that, but in general, that's like one of the tricks with a lot of these models is when you actually try to convert them to video, they get a little flickery. We're basically when that video hits the one with the faces that are flowers, you'll see what I mean. It's very flickery, right? Okay, so next frame prediction. Next frame prediction is actually pix to pix. It's like its own. We call it its own thing just because it's like a very interesting, unique case of pix to pix. So it's a special version of pix to pix, and it uses pairs of images to guess the next frame of an image, or to like it basically learns the translation between two frames of a video. So the training data here is a video that you break into frames, and this is an example of what the pairs actually look like, right? So it's saying frame 0 to frame 1, frame 1 to frame 2, frame 2 to 3. Like to our eye, these do not look like different frames, but if you were to actually like place these over top of each other in Photoshop and add a little transparency, you would see there's like very slight shifts in them, right? So that's what the machine learns. It learns those slight shifts. And basically what it ends up learning is it learns like generic or basic motion. Because again, remember that it's trying to learn how to generalize all of the sample data it saw, right? It's not great at actually learning like each individual frame and how it transitions. It's more just trying to say like, okay, you gave me all this data and I'm gonna mush it together and try to figure out what the translation should always be. That's why it leads to like really messed up stuff, because it just doesn't actually know what it doesn't, like, can't actually learn complex motion. There are new models out that now actually look back 4 or 5 frames. So instead of being pairs, it's actually like, it's a longer period of time. and those learn motion much better. But also, so I think you're to the point, which is like, why would I want it to perfectly learn motion if I just, like, it's already a video, like I'm just recreating what I've already made. So like part of what machine learning is for artists is like, what's the cool thing that is sort of the grounds between like perfect realism and just recreating what I already made, and like actually some interesting things. So next frame prediction will probably be solved in like the next couple of years, and like we'll all stop using it because it's just too good. It will just be like recreating video. Yeah, so what actually happens when you test it is you give it one frame of a video, it learns the next frame, you take that frame that it generated and you feed it back into the next frame. So that's why really quickly it devolves into like chaos. Actually, I just made one today, which I can show you really quickly, which is this guy. So you'll see really early on that it is like perfectly square. Basically, as soon as it hits that, like, basically what it's been doing is I sort of, you start seaming it with a bunch of video frames ahead of time, and maybe about here is when it starts to actually take over. And you'll see it very quickly devolves into like mushy shapes, and then it gets really crazy. So like the thing I like about this is it doesn't know what it's doing, and it's not actually very good, but it generates these really weird shapes.
If I would have to guess, like the thing you fed it is really simple,
Yeah.
right?
Yes.
It's like a clear shape and a clear movement.
Mhm.
So why did it get this way? It seems to be like it's really easy to continue.
Well, it's easy to you. It's easy to use a human, right? It is not easy to a machine. Also, this has only been training for like maybe a couple hours. As you train it longer, it gets better at those representations, but it never gets really that smart. Or like when it does, I'm just disappointed. I'm like, wow, I just recreated the video I just made.
And when you say training, that's about like you feeding back in to say like, okay, when this gets all wiggly, this is wrong, or like is it just like literally a server running and then
It's literally a server running. So the way that this works,
there's no input from you.
There's no input from me.
Huh.
So like basically the way training works for most things is it just keeps repeating over and over and over again on the data you fed it.
Yeah.
And it gets smarter over time. And we'll talk about that more next week when we talk about GANs. Basic GAN is a way for us to like literally do that process. And we'll talk about how that actually works, because once you learn how it works, you're like, oh, that actually makes more sense. But yes, like basically you just set it up. Like I'll run this command, I will set it up at night, I'll check on it in the morning, and it might be like at this state. I'll let it keep running for another 12 hours, and I'll check on it again, and it will get closer and closer to perfect, or like good. Yeah.
Sorry, we don't like necessarily have to talk about this right now, but so say you train your model on that thing, the data set you gave it,
Yeah.
and then would you be able to interject at one point with like so it's like devolving into madness?
Yeah.
Like if I'm like, okay, I want to like somehow interject the square again so that it like that can also take over again, can you do that?
You could do some of that. You just have to like play with it basically. Like you could maybe take a frame down and then try to re-inject the same piece of data into it and see if that like loops back on itself.
Okay.
I've actually never found a good way for these videos to loop. They just sort of always like devolve into madness.
Right.
But it would be interesting to think about, like, could you actually like inject some of that and see if it could like continue itself. Yeah.
So if you only fed it like basically a square, where does the blobs come from? Because it doesn't know about blobs.
So remember in week 1, let me pull up week 1 here. That is not the right thing. I want this guy. So in week 1. Remember these guys? This is what's called a convolution filter. Basically the way that we do images is we take these different shapes and we slide them over an image, and that's how we learn where certain shapes are within the image. The reason you get blobs is because if you'll notice, these are not perfectly these are not perfect shapes, right? It's not completely a 45-degree angle. The reason that we have these convolutions is because they work really well for natural images. So they work really well for finding zebras, finding faces, those sort of things, because our faces and zebras are not like perfectly geometric.
So the machine is biased.
The machine is biased, and when we feed it a very geometric shape, it like fucks it up and turns it into this stuff. That's generally what happens. Yeah.
So there's different opinions of this then. There's different convolution filters.
There generally aren't. Like we just have sort of decided these are the right convolutions. Because most data scientists are interested in finding natural objects and those sort of things, they just keep using the same ones. I'm sure like some entrepreneuring like artist could figure out how to make their own convolutions. That feels like way outside of my scope of interest and or intelligence. But yeah, you could create your own convolutions. And actually, this is when most people hear that neural networks use convolutions, they are very surprised because convolutions generally are not good at this, and not good at finding organic shapes because most people use convolutions to do other things with it, to like sharpen images or to like show outlines of things. Once they see what the convolutions are, they can kind of understand a little better.
Wait, how many convolutions are there in total?
It actually depends. There's a ton of different layers of things that like. So basically, like I think this is actually the convolutions that are probably in most GAN models, but this is multiplied times the number of layers times the number of colors. There's thousands upon thousands of convolutions in a generalized model. Yeah.
Okay, so it wasn't just like that set of what seemed to be like 30 or 40.
That is the first layer of that particular model that he was showing.
Okay.
Other models might have more layers, might have less. But also, again, remember that those, over time, as you get through different layers, they stack on top of each other.
Right.
And that's how they make a feature. So what it's looking for initially is just looking for zebra stripes. Then it combines a zebra stripe with like the back of a zebra, or I guess zebras have manes, right, or whatever. Like different types of zebras have like fluffier backs, I guess. So it finds those things and it builds them up into like, this is actually what a zebra looks like by combining all these features. We'll talk about more about next-range prediction in week 4. I'll show you some certain techniques and other things to like keep an eye on. CycleGAN Munit. What time is it? We got time. Okay, so CycleGAN and Munit. CycleGAN is a little bit like Pix2Pix, but it's a lot stranger in the way that actually works. It uses 2 folders. They are unpaired images. And I'll show you an example of unpaired. But basically it generalizes between 2 sets of images to try to understand how to translate them. So basically what your data sets for horses to zebras, these are literally the images in horses to zebras. If you ever want to look at that model, you can actually download them and just look at them. These are the images of horses, these are the images of zebras. What I think is really fascinating is like in this case you have multiple horses. In this case you have humans. Like the zebra isn't even really like the main focus of this image, and yet it still understands how to translate them. Again, this is like stuff that we as humans probably couldn't do, but mathematically it becomes really easy to do if you like give it a couple hours or give it a couple days, and you just say like, look for this convolution, match them up. Like basically what it's essentially doing is actually doing, you ever do this thing in Google Image or Google Translate, where you take like an English word, translate it to German, then translate it back to English. That's how this model works. It basically, what it actually looks for is how well can I represent the English to English after this other step. So what it'll actually try to do is it'll try to convert a horse to a zebra and then back to a horse. And depending on how realistic that backwards image is, or that last step is, that's where it's trying to train toward. It's trying to train to understand how to convert things forward and back.
How does it know that it's not like a mountain program?
You get 1,000 images of each of these, and it starts to learn.
It really, okay.
Yeah. So it's like if you were to give it 1,000 mountains, it would sort of learn like this one's actually important. Like if you have a single mountain in a data set of 1,000 zebras, it's going to learn that a zebra is actually what you're looking for.
Okay.
Which is why like a random person of like a person like getting a manicure or something next to a zebra, I don't even know what's going on there, but like it's going to eventually throw out this data because it sees enough other zebras.
So you can in CycleGAN having like a really compositionally diverse set around like the same subject.
Yeah.
Kind of is good.
I would say it's not good, but it can work.
It can work. Okay.
Like again, this gets to the point of like a lot of data scientists or people who are trying to like make these models. Their emphasis is not in collecting good data. Their emphasis is in like making a network that actually works.
Gotcha.
We as artists should probably think about how we would actually make a good data set, because a better data set is going to get better results. That's the important thing to know. Or like, it's actually a little bit debated within the science community, but like in general, it will learn certain things that you want it to learn, right? A lot of what we're trying to do is we're trying to like sort of like throw some spaghetti at a wall and hope that the machine learns to catch it, but like it doesn't always catch the things you expect it to. And that's important to know. Is like in some cases what it might actually learn, and so in the case of, I don't know if I have the video here. I don't have the video here, but like if you remember that video, what it also learned were that like zebras are in like the desert, right? So it actually changed the background color of these images because of all the other data it saw, right? So in the case of like, it kind of learned how to train a horse to a zebra, but it didn't really learn like, I just want to train a horse to a zebra, right? It also changed the background, it changes other things. And that's a common thing we see in machine learning, is that what you think you're training it on is actually something else.
So if you have like other hidden kind of biases or points of consistency, it'll pick up on that too.
Yeah, it will, yeah. So one of the things that you'll like, there's a funny joke, there's a machine learning artist, I'm blanking on her name right now. But anyway, one of the things is that there is like a classifier, an image classifier on Microsoft, and like whatever their one of their like machine learning models is. And what she noticed is if she fed blank images of hills into the model, it found sheep. And the reason is that the machine learning model learned that sheep were in hilly areas. And like there were often like photographs of sheep where like the sheep were like this small in a big hilly area. And it didn't learn what sheep actually look like, it learned what a sheep's environment is. And that's really common. Like you will see that happen very often in machine learning. The way you think it's learning is actually something else. It's learning the environment you're feeding it in and not actually learning what you're expecting it to learn. So that's where a better data set would actually be helpful.
So if you were like the most diligent person, you would make sure to crop out every element that wasn't a zebra or a horse before feeding these images in.
If I were the most diligent person, what I would do is I would actually I would find photos of horses, and I would find photos of zebras, and I would silhouette all of them.
Right.
And then what I would do is then I would take the horse,
You'd mask everything.
I would mask everything out, and then what I would do is once I've converted them, I would bring that zebra back in to like Photoshop and layer it over it so I didn't have the background change. But like that's a lot more work, right? So like no one's gonna, or like most of us aren't gonna do that. And the Scott Eaton, who I talked about in the first week, has a similar thing where like what he tried to do is he was training his figure drawings on photographs. And what he noticed is that if he had photographs of very different lighting situations, the outputs were very muddy. So what he did is he actually brought a bunch of models into his studio, photographed them with the exact same lighting, and then when he drew them, they matched up exactly the way you expect them to. So this is really like, this is where it's like, how crazy do you want to get with like making your data set perfect? In a perfect environment, you have like a photo studio, or you have like hundreds of illustrators that can draw exactly what you want to, and then you can generate these things. Most of us don't have that. So that's why there's always like this little bit of fuzziness in a lot of machine learning models, because like we're generating off of like kind of shitty data.
Question: what was the output in StyleGAN unit?
So the output is, so basically like you train it on A's and B's, and then the input is you feed it one of these images. So like now I want to feed it a new image of a horse, and it converts it to a zebra. So similar to Pix to Pix, it's like what you feed it and what you expect out of it can be flipped. So you can feed it a zebra and get a horse. You can feed it a horse and get a zebra. But whatever you train it on, you can't throw it a mountain and expect to get a zebra out of it, right? It just like, it doesn't know how to translate those two. So the difference between CycleGAN and Munit. So I used to teach CycleGAN, now I teach Munit. CycleGAN gives you one image. It's what's called deterministic, meaning that it only ever finds one image based on your input. Munit is actually a little different in that it can actually generate multiple images out of one input. And that is like, the difference is like color or noise or like other things. It's not drastically different, but it will be just different enough that like what I think is like an artist or a designer, like you kind of have some options you can choose. Whereas with CycleGAN, you get one photo and that's it. So if you feed it the same horse photo, you will always get back the same zebra image. So this is an example of, this is an example of ramen to people, but this is actually an example of how it actually learns. So it goes ramen to people, back to ramen. And you'll see it's fuzzy, but like to the machine, these two are pretty close, right? And that's how it learns. It just does this over and over and over again until it gets to a place where like this image and this image are pretty close to each other. And that's when it's like, hey, I've learned how to translate these two.
And you create pairs, or like the people set is a people set and the ramen set is a ramen set?
Yeah. So you just feed it random images.
Okay.
And basically what it does is it actually tries to take this image to every other image you've given it. So again, it generalizes towards something, right? It says, if I want this image to go to match to any face image, here's how it has to translate. And yeah, so that's why training takes forever, right? So it's like, training something like this probably takes a day or two.
How
but-
big do you think the data set is for this?
Oh, this is probably like 500 photos of each, I would guess.
Okay.
But it does it across, so it's like, I don't even know what the math is. It's probably like, what, 25 million or something like that at the end. There's so many combinations, and it does that over and over and over again. That's why we need a GPU, because to do that math, like on a graphic, basically it's on a graphics card, it's actually set up to do that math really quickly. If you do it on a CPU, which is just like a generalized, like what your computer has, it'll take like 50 times longer. So like this goes from like a 1-day job to a 50-day job. And all of a sudden, like that sounds like insane, right? And the other thing is, so like just like pix to pix, you get both translations, right? So you get A to B, but you also get B to A. And that's sort of like, so what's interesting is like the machine is learning this extra step, but what we actually want are these two steps. Or what we actually want is the B in this in both these sets, right? So we might feed it a face and we get back a ramen, or we might feed it a ramen and get back a face. But what the machine is learning is actually this extra step. Okay, StyleGAN. So what does StyleGAN do? It generalizes the features of an entire training data to produce new similar images. So unlike the other models like Pix2Pix or CycleGAN, where Pix2Pix and CycleGAN learn translations, right? So they're translating from A to B. StyleGAN learns a generalized model of all of the images you feed it in a data set. So there's no translation, it's just generalizing all of the features. So the training data for this is usually a lot of images, right? You can almost think about this as like, this is A plus B, like in folders, right? You actually need double the amount of data because you're really trying to generalize both sets of these things. So you need a lot of images. 1,000 is like the floor, like you really need more than 1,000. So on the faces, the famous like FFHQ dataset, that's 70,000 faces. So that is a lot of faces to find. It turns out it's easy to find faces because we're all like self-centered and we all take photos of ourselves. But let's say you want to find like Kandinsky artwork. I don't know how many pieces Kandinsky made, but I bet it's maybe at most 1,000, right? So there's no way you can find 1,000 other pieces or like 50,000 pieces of an artist. This is why StyleGAN works really well for faces, and other places it gets really tricky because it is hard to find that much data. This is the challenge of StyleGAN for most of us, is like finding the right amount of data for this is really hard because you need a lot of it.
And if you kind of like under-train, would it create blobby things or more of what you fed it?
It's going to do what we call overfitting, which basically it memorizes what it sees, and all it does is spit back the same image you already fed it. And like, again, what's the point of that? Like, you just spent $50 and all you got back with the same image you fed it. Doesn't seem like it's worthwhile. There are some reasons why you might want to do that. I can talk about that next week. But yeah, in general, it just like isn't really great. So these are actually the faces that are in FFHQ. So they found 70,000 of these. They're all pulled off Flickr. Maybe your face is in here if your face is on Flickr. You actually don't know. But what I find really interesting about all these faces is these are not good photographs of faces, right? These are not good portraits. Like, some of them are twisted a little bit. The lighting on all these is really kind of bad or crappy in many of these places. But
Crops of the top and the bottom of the head all vary.
so what they do is they actually align by the eyes.
Oh.
So all the eyes align and most of the faces align. So there's like a machine learning model that will actually like find all these eyes and like align them perfectly and then match them up. But yeah, but like the lighting here is like, this is an outside photo. This is like inside. Like there's like, what I find really interesting is the model still learns a lot, but like imagine if you actually did real portraits of like 70,000 people with the exact same consistent lighting, you would get a much better data set. But no one's gonna go to that work. Or like, it's gonna be a lot harder to do that work. Okay, so we talked about this a little bit earlier in the week, which is that how this thing actually, like what it actually produces is okay, so this was the training data, right? So you need a lot of the images for training data. The input is technically not an image. It is a 512 dimensional vector. So we talked about that here. What you get out of that is an image. So again, like there's no translation, right? So there's no way to actually say like, I want this image out of it. So we had to find, like, so the people who made this model had to find a new way to represent, where do I want this image from? And what they came up with is this what's called latent space. spaciest space. You say, I want an image out of this particular point in the space, give me that image. Ton of math that goes into like mapping these things and that sort of thing, but that's essentially what it is. Any questions about models? I know I threw a lot at you, but like you'll also learn them a little bit more as you actually train and work with them.
Are we up as a single image, or can you like throw in, you know, noise to?
Well, so noise is going to change the vector, right? So like you're actually giving it a different vector point.
I see.
So you're saying for motion, you put in vectors that align either in that circle or through that.
Right. So one way you could do this is if you think about these as vectors.
Yeah.
Then you think about them as coordinates. Let's say you want to start at -1 for the very first spot, and then it like doesn't matter whatever. Like let's just say all these are the same afterward, and then you like the next one would be -0.999, and then you've got all the same spaces for this. That is a way to you could do that all the way down to 1. Wow, that's terrible. You do that all the way down to 1, whatever this is. This would give you an animation by like generating all of those points, right? Like that is basically like what you're gonna get is an image that kind of barely changes over time, but that'll give you an animation. And all work like a lot of the techniques that we'll use will actually just be like, I actually don't care. We'll do the math between these 2 points. Like you'll say, I want this vector and I want this vector and I want 100 points between there. It'll do the math for you.
And then it'll give you all those images.
It'll give you
And
all
then
those
you'll
images
take
as frames, and then you
Okay.
can generate those frames in. We'll mostly use FFmpeg, which is like a terminal command line way to actually combine video. You could use After Effects and like bring them all in, and then sort by sequence, but it like doesn't. It's not worth your time to do that. There's command line ways to do that. What you'll find is this is using this technique. Like if you were to manually do this, sucks. Don't do it.
Yeah.
You'll get like a shitty image. What I generally do is I will actually say, I'll actually generate a bunch of random images. So I'll say I'll generate 1,000 random images, and then what I'll do is I'll manually go through them and I'll pick out my favorites, and they're basically assigned a seed number, so they'll be like 0, 1, 2, 3, 4, 5, 6, all the way up to 1,000. And I'll say what I want to do is I want to go from 1 to 5 to 300 to 450, and then I want to go all the way back to 1. And I'll say I want to do that, and I want to do that in a minute. And what it'll do is it'll actually figure out your vectors, and it'll figure out all the interpolations between there, and it'll just start generating those files. So again, this is why math is better done on a computer than our brains.
Yeah.
This is basically the technique that I do to produce most of my videos. There's one other technique, which is that like sort of imagine your space and you're like looping through it. The problem with this space is there's no guarantee that each of these images is good. This says, I know that I like these images because I already looked at them.
Is
And
there a
it'll
way
pull
to,
in between.
Yeah.
is there a way to start something out in Runway where you have a GUI interface to see what path you'd want,
Yep.
set it, and then like pull it in terminal?
Yes, there is a way to do that. I haven't seen anyone do that. Generally what we do is, or what most people that I've seen have done in Runway is they'll pull down whatever the vector is they like. They'll like you can download that vector like I showed you, and you get 512. And they'll say like I want to start that in one of these places on the path, and then they'll just generate a random like sort of loop to get back here. The truth is, what actually ends up happening is you get like a point here, like that's where this vector actually is, and when you add all this noise, it ends up being a little different, but you might end up seeing something similar to it.
Okay.
Yeah. This will give you like a really seamless animation. Like it'll feel really, really seamless. This will give you something that feels a little bit less, like it'll feel a little bit more like it'll go fast in moments, it'll go slow in moments. And the reason because of this is that imagine you're in this space. And imagine that point 1 is here, point 5 is here, and point 300 is over here. So you're going from here in 30 steps, and you're going from here to here in 30 steps. This is going to be much faster. But what you will say is, I know this is a good image, I know this is a good image. It's just different. It just depends on what you want to do. But that's basically the technique. Yeah.
Is StyleGAN the only model you can browse the vector within?
There are other models that are like StyleGAN that you can browse vectors in, but I don't teach any of them for various reasons. One is most of the models that I teach you can train yourself. There's a model which is called ByGAN, which is a model by Google. And I was basically trained on like, I don't know, something like 1 million images over like 30 servers. Like you just can't do it yourself. We can explore those spaces, but someone else has trained them. So you can get cool images out of them, but it's not like an image you made or an image that you like sort of decided to make. Yeah. Okay. 30 minutes. All right. Well, I probably won't get to the dataset tools demo, but I'll do a video of it for folks. Okay. So you might be asking yourself at this point, like, okay, what do I do? So I've listed these. This is probably pretty obvious, but I've listed these from easiest to hardest. Actually, 4 and 5 might be the thing that maybe people didn't realize, but it's very easy to do style transfer. You can find 2 images. It takes 10 minutes to actually produce the image. It's like very quick. I recommend that everyone play with that just because it's kind of fun and you can make some weird stuff. You'll also learn a lot about how machine learning models actually look at images. One of the things I'll tell you is is that you might think that you can train like a gradient as a texture, but a gradient will never work as a texture because of, remember, those convolutions. Convolutions are not looking for gradients; they're looking for hard edges. So things you would think like, oh, I can map this gradient color to this image doesn't really work. So some interesting techniques that you can find through that. Second is next stream prediction, right? You can find a video on the internet. That's not hard to do. And like most of the stuff to separate into frames is automated for you. In CycleGAN, you can vary a lot between your image sizes, right? You can have like 250 in one folder and 1,000 in another folder. So you've got a little bit of flexibility there. Next, I would say StyleGAN is hard to find 1,000 images, but it's doable. Last, I would say it's pix-to-pix, which is hard because it just is a lot of work. It is like, if it's something you can't get a automatic segmentation map out of, it's just gonna be a ton of work to do. If you really want to have total control of your artwork, that's the best one to do, but it's really hard to do.
So this is easiest to hardest just in like prepping the data set, not in like math or coding or...
Well, we're not going to code anything in this class, so yes. I mean, I would definitely say like if I were to rank them by like actual math, like StyleGAN is the hardest, but I actually say probably style transfer is the next hardest from there. So again, like what we sort of learn in this class are these things. We will learn next stream prediction, I think, if people want to learn it. If people are really interested in Munit, like basically you sort of have to choose between like Munit, StyleGAN, or next stream prediction, like pick 2, and we can learn that in class. I have videos for the other ones, so like if you ever want to learn them outside, they exist. Okay, so what makes a good data set? So at the bare minimum, if it works, it's good. Like that's like a definition, right? Like horses to zebras, you could argue is not a good data set, but it works. So cool, it works. The next thing I would say is like something that works really well, which I think you could probably improve upon horses to zebras if you had a better data set, right? So we talked about like how would you actually change it. I might remove those images of people. I might try to actually do some color correction around like backgrounds maybe to try to like maintain some stuff there. It would work, it would be better, it would be cool. I think the best data set imaginable is the Scott Eaton one. I don't expect anyone in this class to do that, but it is like, we should be aware that that is the best way to produce a data set. So if you make something explicitly custom for your data set, it'll be much better. So I'll talk a little bit about scraping. If you're not familiar, scraping is a way of like going onto a website and pulling out all the images. This happens to be Google Images. I typed in something like Galaxy or something like that, and these are the types of images I got back. And you can see here that like you could say like you might actually train this and it might work just fine. Actually, you know what? This is from the Nebula's data set that is in Runway, which means like there's some crappy shit in there, but it still works. But like you can look at this and say like clearly that image on the left is a Photoshop job. I really shouldn't use that. This thing at the top here is like too many of the things. Like if I were like actually this is a great image to find. If this is high res, I would pull this out into Photoshop and crop out each one of those, and I would have like a 200 image data set just from that one image, right? So like finding images like that is like gold, but you guys do some manual work to get it. Thing on the right, clearly a logo, clearly not a galaxy. Wouldn't use that. And then you've got these other images where like these are good images, but they have logos in them, right? So like the job is like, do I crop this out? Do I just let it go? Like this is like the level of like how much detail how obsessed do I want to get with this stuff? This also gets to that diversity question, which is like, how diverse of a data set is this? Like, do I actually want it to learn to produce something that looks like this thing on the left? Maybe. Like it's got good texture. It's kind of interesting. It might not learn the actual hand shape. It might just learn the textures. We'll have to see. This is the art of data set production. You just have to like guess, like what of this is good, what of this is valuable to keep, what of it isn't. You're gonna have to train it and find out. So as I mentioned earlier, this is FFHQ. Is this a good data set? It trained really well. It made some really amazing images, but like clearly the photographs are not like well lit together. Compositionally, they're kind of all over the place. Like I would say they're not good photographs of people, but like they work. So it's an open question. These are data sets from my own work, and you just again you have a question of like, what do I do with this data, right? Like I think like 1 and 3 will work pretty well, but like 2 is like now on a white background. It's now a bunch of different images. It's a different artistic style. Compare that to like this one on the end here, which is like also a different background, but has more of a alignment of collections. Basically what it comes down to is like what model am I trying to learn on and how much other data do I have, right? So if let's say I only had 500 images total of 1 and 3 of that style, but I need to do StyleGAN. I might have to start injecting some other stuff into it just to get close to what I need. There's other techniques we can use to sort of like augment our data set, which is a lot of what the tools that I use are. So a technique where you can flip images. If you flip an image, all you're doing is saying like, it's okay if images are read left to right, or like in the case of a face, right? Our faces are fairly symmetrical. You can say like, it's okay if like an image, like if your eye like is a little bit lower on this side and now it's on the other side, like those are techniques that are good. I'd still say your floor is 1,000 images, like just of raw images. There's another technique you could do where you could crop in on these a little bit and have them be the same size. Again, that tells the machine that like it's okay if the scale changes a little bit. This is a big art. You just have to like sort of figure out like what can I do, what can't I do, how many images do I have, what am I willing to get away with, what are other techniques I can like tweak things, like that sort of thing. I've seen a lot of people try to do shearing, so basically like sort of warping an image a little bit. I find that those don't work as well as you would expect, but they are a possibility. So if you're at like 800, you might be able to get it creeped up to 1,000 by doing some of these techniques.
Can you juice a data set? Say you have like 500 images or something that has bilateral symmetry. Can you like put like just flip in Photoshop and a batch action and then put the other 500 in and then like it's good? Or does that like
not really?
Not really?
Or like you realistically, like if you have 750, you might be able to get away with that. If you have 800, you might be able to get away with that. There's like a threshold.
Yeah.
And actually most models have built-in bilateral symmetry.
Oh, okay.
So they actually do it for you, so you don't need to do that work.
Okay.
But yes, you can sometimes get away with it. Like what actually is really helpful if you have an image that can go like horizontally flipped as well as vertically flipped, like then you've got like some gold there.
Yeah.
Which is why like stuff like the galaxy stuff, like you could probably make that work.
Yeah.
The way I describe it is like any image you're feeding to the machine, you are saying this is an okay image to repeat back to me essentially. As it doesn't actually repeat it back to you, but it's like this is a accurate image for you to learn from. So some images can't be flipped left to right, right?
Yeah.
Like if you want like, well, text doesn't work really at all, but like if you wanted to say like I wanted to learn like text, you can't flip letters left to right, right? Like it's not realistic. There's probably other images I could think of where like flipping it left to right would be bad, or flipping it up and down. Like up and down is almost like you don't want to face it upside down. That just wouldn't work. Or like it could be cool to actually see what that does, but like yeah. So it's like sort of like what you're feeding the data set is saying. You're like, I think this is within all the realms of possibly good images for you to spit back at me in some way or another. Yeah. Eventually, everyone asked me about copyright. Copyright laws are weird. They're all over the place. I think the argument is that you are making a new work. You could maybe get away with it. I don't know. I've never seen anyone sued for using data sets yet, but it's probably not far off. Generally, the way I think about it is that if you are playing around, like in this class, and you're making stuff, you should do whatever you want to do. If you are starting to share your work, or if you're starting to sell your work, you should think about ethics a little bit more. I know that in like some cases people have like, so you can scrape Instagram, you can scrape someone's entire Instagram feed. So it means you could like take all the art from someone's page and like put it into a model and like spit it back. You should think about whether or not you want to reach out to them and let them know you're doing that, or if you just want to do it and not tell them. Your ethics are your ethics. My personal belief is that in this class you can do whatever you want. Within bounds, like don't steal pictures of kids, like that's just gonna get you on some FBI list. But like, you know, like do like within certain bounds, like things are I think reasonable. And obviously we can talk, if you have questions we can talk about those. But in general, like, you know, just think about what you want to get out of it. In most cases, I think most of these images produce fucking weird shit anyway, so no one's even gonna, like, most people are not gonna be like, that's my image right there, right? Like, your face might be an FFHQ and you probably couldn't tell. They will never figure it out, right?
Yeah, I don't think we have anything to worry about. Like, and you could
Yeah.
argue it's transformative.
Yes, yeah.
It's,
Fair use.
yeah, it's like, especially if you're doing it for art.
Yeah, but if you make money off your art.
Well, even if you're making, let's say you put it in a gallery and you sold it, like that is still transformative. You know, like it's just like
Yep.
people.
Everyone has their own level of what they're comfortable with, and I would say like use your own level. But like if I do see something that I feel is like unethical, like I might say something to you, and we might just have to have a conversation about it.
Is there much of a discussion about the evolving precedent around usage, or like, I mean, do you know any artists using StyleGAN that have gotten sued?
I don't know anyone that's gotten sued. I mean, I think FFHQ is a really questionable data set. They literally scraped all of Flickr, and if you have a, like, if for Creative Commons, like, you can say, like, it's okay to use my image.
Yeah.
So they scraped that based on that. But, like, your Creative Commons use is not, like, I don't think most people are saying, I'm okay with Creative Commons, thinking that, like, their face might end up in one of these models. And the thing about a lot of these models is, like, if it's my face but has a slightly different beard color, like that isn't transformative to me, but that is a potential output of this model, right?
Yeah.
So this is where it gets murky. I would also generally say like avoid faces. One, because someone's already done it and you can just use their model and like do whatever you want with it. But also any machine learning model that gets better at training faces means it is better at a surveillance state sort of detection, right? So like just think about those things. I don't think Google is like actively watching this class and saying like, what did they learn and what can I steal from them? But there's ways in which these things become like, oh, well that's an interesting way, like I can take that and use that. So for example, super resolution. Super resolution takes small images and makes them bigger. Guess what? That means that someone is out there taking license plate images and blowing them up. And like, so there are ways in which any of these models can be used in a really shitty way. And like, we should think about whether or not we're inventing a solution that maybe someone will look at and be like, I can fuck with that. Most of those ideas are already thought about, but like we should think about whether or not we want to introduce them to the world. Yeah. Just something to think about. Yeah. Okay, so data sets, ways in which you can make them is you can take a pre-made data set. There's a lot of data sets online. You can just grab them, download them, do whatever you want to do with them. You can cobble together your own. So like one thing is, let's say I want photos of leaves, right? There's already some data sets that have leaves in them. I could download that data set and I could augment it by adding in my own photos of leaves or finding photos of leaves that I found on Flickr. Like that's totally reasonable. You can of course scrape the internet, which is like not necessarily cobbling together your own data set, but just taking all of the massive data on the internet and like putting it together. Or you can make your own. Obviously, like for this class, like the first one's fine if you're like just interested in playing with a model. You won't really get that interesting results. I would also say it's a waste of your time and your money, because if there's already a data set, someone's already trained on it, you can just use their version. Cobbling together pieces, totally fine, works. Probably the easiest version of this. Scraping the internet is cool, but it is, I'll show an example, but it's a little bit of a nightmare. And then you can make your own. Making your own is like really cool, but like I don't expect anyone in this class to do that, especially in 4 weeks, but it is a thing to think about. And then of course, like I said, this is easy, hard, really fucking hard, like all this stuff. So Google is your friend. One thing I like to do is if you're just trying to figure out like how big of a data set do I really have, you can always Google stuff and see what sort of results you get. So something like shoes data set, well, you will definitely find a shoe data set. If you're looking for something specific, like say I want vintage Nikes or like vintage Nike ACG boots, like as a data set, that will not exist as a pre-made data set. I can tell you that today. But if you do Google vintage Nike ACG, you might find someone who is collecting photos of those things, and you might reach out to them and say like, hey, would it be cool if I like download this data set and like made my own version or like made a cool like machine learning model out of it? And they might be cool with that. Or you might just like say like, fuck it, I'm not gonna ask them, I'm just gonna download it. It's the internet. People do weird stuff. But like, again, think about like what are you actually looking for and how generic can it be or how specific can it be? So again, shoes data set that exists. There's like a bottle caps data set. There's all sorts of weird data sets you could download. And it just depends on if that's exactly what you want. So you can find pre-made data sets. Golan Levin, who's a teacher at Carnegie Mellon, has a public Google sheet that is all data sets that exist that his class or other people have found. So if you just want to find other people's data sets, that's a good place to start. It includes links, it includes downloads, like other things, other like little pieces about it.
So there's a preview?
No, you basically have to go to URL and like see what's there. A lot of times it's like this is a collection of images and no one has compiled it into a zip, so you gotta do the work. Scraping various image sites. I've recorded videos of 3 different scrapers that you can download and use. You can scrape Google, you can scrape Instagram, you can scrape Flickr. I have demos of those. I will post them tonight for you. So if you want to like scrape any of these sites, you can do it. In the case of Google or Flickr, like you can have different search parameters. In the case of Instagram, it's like you just scrape someone's account or a hashtag. So
like
it's
incompletely.
incompletely, yes.
Like if I hashtag,
Oh my
wait, well,
God.
how, I mean, if I do like hashtag blessed, like how do I set a limit? To that?
There is like a limit, and there are limits to setting to that. But like you could essentially like download millions of images, I think, if you wanted to. Yeah.
That's crazy.
Yeah. So
I
like
love that.
most of you don't know that happens. Any one of your Instagram accounts could have already been scraped. It probably already has, but like for other reasons. But yes, the first week of class, or the first time I taught this class, I like just sat up here and like just scraped Braulio's page, and he was sort of like, "Wait, what are you doing right now?" So yeah, so it's totally possible.
When they don't block it in any way?
If it's private.
No.
anyway.
So it's private. You will have to log in with your account, and if you're following that person, it'll still work.
Oh.
Crazy shit. I haven't been like shocked this works, but it does. The thing to know about all of these is that they will be a little time consuming. You're getting a lot of crappy images in your data set. And then creating your own, it's awesome, but it's like time consuming. Most often I find them doing a mix of these things and downloading pieces. I might be manually downloading a couple images I think are really cool because I want to augment my data set, those sort of things. This is the most time consuming part. Like I've had feedback where it's like, when you teach this class, can you give us like 2 weeks between the next class so we can have actually enough time to do this? Unfortunately, no one's schedules like I can't tell SSHH that like I want to take a week off. They're like, that's not going to work for our class schedule. These are the demos. You can go ahead and grab them. There's also one called Image Downloader, which is a Chrome extension. And basically what it does, if you're on a web page in Chrome, you can hit download and it'll download all the images on that page, which is pretty cool. The problem with that is most of the resolutions of those is bad. So you just have to sort of see what it is. I won't go through this because there's demo videos for all this stuff. But let's just say, for example, like I'm going to scrape Instagram. I now get like 3,000 photos. And now I need to figure out how to actually build a data set out of them. So I have a library called Dataset Tools. There's a bunch of features within this thing. There's ways to reshape or resize all of your images. There are ways to do cropping. There are tools for sorting. So one of the things is if you're doing StyleGAN and you want 1024 by 1024, old Instagram photos were like 600 by 600. So guess what? You can't use any of those. So the sorting function will just toss all those out for you. I built this up over the past 6 months just teaching these classes and just finding what people need. So there's a bunch of different ways you can do this. This is the basics. There's a better, I'll record a better video of this because I want to get through this. I'll lead you through an example of just like creating a data set. I just did this one day using Bone photos. If you've never seen Bone, please follow Bone. It's a cute cat. So this is basically the process I go through. I'll scrape images. I'll toss out images that are too small. I'll toss out duplicates. Then I go through and hand curate. And then there's like this other thing of where I need to resize or crop them all as squares. So StyleGAN is mostly square images. There are ways to do a non-square, but for this class I'm just gonna say just do squares because it's insane otherwise. So we need to resize, crop. Maybe you'll do some of this augmentation stuff we talk about, like flipping or doing some little scaling tricks, those sort of things. And the last part is like someone has to go through all of it and like actually look at all of them. Yeah.
Would you be able to upscale images using the same techniques we're talking about?
You could. I don't find it like it's good enough, but you could. If you're really desperate, I think it's worth looking at. Yeah. Okay, so yeah.
Is it technically like you can't feed smaller images because it's the technical?
Yes, technically, like as a mathematic thing, it has to be the exact same size. That is true of Pix2Pix, and that is true of StyleGAN. CycleGAN doesn't really care, but it does some cropping to actually like do the work. Yes. Okay, so like here's what I would do for Bone. I've scraped Bone's Instagram account. I now have 2,400 images. I'm like, great, this is gonna work really, really well. The first thing I do is, okay, so this is how I scrape them. The next thing I do is I remove all the images that are smaller than 1024 by 1024. Guess what? That cuts my thing in half. That is very common, especially with Instagram, because Instagram like 3 years ago only had small images. So this is like a very common. This will also happen with Google Images. Like Google Images will give you way small images, and you will like, all of a sudden you're like, shit, now I don't have enough images, right? Like this is a very common thing that happens. Okay, so now I'm also gonna say like, hey, I don't want, this is deduping. This is the wrong slide. Oh, this is, okay, so now it's like, I noticed as I look through my data set that 2 of these images are the same, right? So I need to toss out image duplicates. Realistically, that will not give me just get rid of 1 image. So a lot of Instagram, especially like influencer accounts, they just screenshot their own images and they like crop them and they repost them like every week. And like, guess what? You get a shit ton of duplicates, and they also have different JPEG compression. So you actually have to like figure out how to mess, like, I have a whole library around like just messing with compression levels and like making sure they match. That was a pain in the ass to write, but you will find a lot of duplicates in your data set too. In this case, it only removed 2. That's great. Then you've got these images where like these 2 are really close to each other, but they're not the exact same. So I do have a library in Dataset tools that will actually remove these if you want them. But like you've got a question here of like, what do I actually do with this? Is it okay that 2 of these are the same? Think about this like a statistic model where it's like if you have a bunch of data and like you've got like you've got a little cluster over here, like this is gonna throw off your model, right? So if these didn't exist, the line would be here. With this, it's actually it might pull it this way. So you have to think about stuff like this. In the end, it probably doesn't matter, but it's worth thinking about if you have like somehow like a whole video of frames got put in there. That's gonna alter your the model's perception of how the data set works. So you might have to manually do this. The next thing is you've got to hand curate some of this stuff, right? There's a question here of like, is this a good image? Is this a good image? Like, what of these images should I actually keep, right? Do I want Bone Bone's face in every photo? Well, that's not his full face. Or am I okay with other people showing up in the photos? What am I trying to do? So this is where it becomes like the artist, where you're trying to say like, this one's good, this one's good, this one's bad. Going through 1,000 images is a shitty process. It sucks. In general, what I do is I'm like watching TV and like half watching a bad TV show, and I do this. This is basically my weekend, which makes me sound really sad, but that is basically what I do most weekends. The next thing you need to think about is like these are all rectangular images, right? And if I want to use StyleGAN, I need to crop them to squares. So now the question is, how do I crop these images to squares, right? So here's an example of where I just center crop. This is very easy for a computer to do, but guess what? I've cropped out Bone Bone's eyes. This middle image is good. This one is so-so, but this one clearly doesn't work, right? So then it's like, well, what if I do a top crop? This would also be very easy for a machine to do. This works better for these, but now I'm cropping out his feet and keeping more of the human here. So this is now like, what do I do? Like I could go in and manually crop all these. Now that takes way more time, but I might get a better data set out of it, right? So this is where it becomes a play of like, do I want to spend 5 extra hours cropping each one of these images by hand, or am I okay with just running it and just sort of seeing what I get? Most cases, you'll just run it and see what you get. So but it's like these are the types of things you have to think about when you're creating a data set. This is no different than like what data scientists do with all of your data, all your Facebook data, is they have to figure out how to massage your data into a place that is a solution that they can use.
What happens if you take everything and you're like, all the vertical images, I'm going to put them onto a white canvas that's square? Like,
yes.
It's then like the machine will be trained against like letterbox.
Yeah, what'll usually happen then is if all of your images are not like that, so you'll have a square image and you'll basically get like weird bleeds at like edges. So we'll sort of learn, but it'll like get weird, which is totally fine. But that is a technique as well. That's also a thing that in my library that you can do. Another technique would actually be, I don't know if I have it here. I don't. Another technique is you can actually, oh, it is here. Yeah, this is right. It mirrors the data that's there, right? The question is this now going to learn that anytime I see an ear, I need a reflected ear? It depends on how many images like this are in your data set. Here, the same thing. It's like, is it going to learn weird body shapes? It just depends on how many, it's all a statistic model. Like it all comes back to this, which is like, what are you telling it is a common feature and what are you telling it is uncommon? If you have 2 of these images in 1,000, it's gonna be fine. If you have 100 of these in 1,000, it's gonna be bad. So you kind of have to just see like, what does my entire data set look like and how do I make this work? Okay, so got 3 minutes left, great. So these are a bunch of the options that are available within the dataset tools. So basically the way this works is you have to go in an input folder and an output folder. So you point it at one folder of images, maybe it's a scraped image, you tell it where to stick them all. There's a bunch of process types in here. I cannot guarantee that all of these work, but I can at least fix them if they don't work. I would say most of them do. I think the one that I'm like unsure about is the pix-to-pix one. But most of these do work. I've actually added more of these recently. So you can crop the square. So crop to square is basically that center cropping. Square is the one that mirrors it, or you have some options here. So against you got border types, or sorry, where is it? Yeah, border type. So stretch is the one that actually just, it takes the pixels of the edges and stretches them. There's a reflect, which is the one we showed. And there is a solid, and that's what you're talking about, which is just put it on a solid color, and you can choose your color here. So basically, I'll record a video of how this works. If you've ever used terminal with Python, it's pretty straightforward. Basically, what you do is you use a command like this at the top here. So in terminal, you'll say using Python, you want to use the Datasets tool library, and then you want to give it an input folder, an output folder, and the process type. There's a bunch of defaults. I'll record a video for how this works. But this comes installed in your library once you install everything. So second thing to know about this is you can run this library on your computer, on your desktop. So one thing you might want to try is actually just try it out locally on your computer, just to make sure it's building the things the way you expect it to. The problem with that is if you have a StyleGAN model and you have thousands upon thousands of images, they're going to be big. It's going to be really slow to upload that to PaperSpace. So sometimes you want to do this work on PaperSpace, sometimes you want to do it locally. It's just sort of up to you what you feel most comfortable with. Okay, so your homework. I'll stick around for a little bit after class if you have questions about PaperSpace or other things. And I'm happy to do like demos if you are interested. But essentially what your homework should be for this week is like, one, to set up your PaperSpace machine. So if you haven't already, like definitely try out the video or DM me and we can like set up some time to walk through it. That's the most important thing. And then I think you should figure out what you want to start making. And with that, you need to start making your data set. So if you're like, I really want to go all in on StyleGAN, I need to start finding thousands of images. How do I do that? Like start thinking about that. One thing you can do is you can start to like just look at Google Images, see what's available and be like, oh, are there ideas here that I can start playing with? Or like, maybe sometimes the best way to do Google Images is like do different searches, right? So it's like boots versus shoes versus tennis shoes, like, and just sort of see what's available. So again, like think about what your data set is, because that's really important. And I'll say like, it also depends on what you want your outputs to be. So these models produce videos. There's an asterisk here because, as I said, this one is a little tricky. These produce static images. So if you just want to produce static images, these are good ways to do it. If you're interested in like printing stuff, I would say Style Transfer, you can get pretty high resolution images. You can get like 1600 by 1600 pretty easily. And CycleGAN can do some higher resolution stuff. StyleGAN is actually a little bit tricky because 1024 by 1024 is the max. You can use those super resolution networks. A lot of them are in Runway. If you want to look at them, I'm happy to link to them as well. But it does get a little bit trickier to make high res stuff for that. Okay, and then make a data set. That's it. Any questions? Or any questions that I can answer now that don't require you to like actually do all this work and then have more questions?
One technique that I'm interested in is taking one super large image, like a map, and then cutting it into different like pieces. What makes a good image to cut into different pieces versus one that like maybe won't get as interesting results?
The higher resolution the image, the better off you are. You can crop stuff into bigger, smaller pieces. That's actually how this video that's playing now is produced. Actually, let me just show you how I think I have this here on my desktop. Let me just see. Yeah, so the way that I produce those images is that I run the same command over the same set of images multiple times, and I just crop different places. So let's say there's 400 images total. I'll do like just a straight up center crop of all of them. And then I will do another one that shifts to the left a little bit. Right, so you can see that's the left side, the edges. These are so this is about 400 total images. You'll see there's 400 total images, and I'm cropping them all the exact same way in each set. Then I'll do a right crop. Right, so this is the right edge of these images.
Why aren't these squares?
Oh, okay. So You can do non-square StyleGANs. I don't recommend it for this class because it's like advanced mode, but you can do it. That's what I'm training here.
But your final video is square, so is there some?
That video is square. It is square crop for that one.
Okay.
I'm doing a different. This is a different model. I just don't have that data set available to me. Yeah. So like this is a way to do it. So now I've got a top crop and a bottom crop. You basically like imagine like every image, like say all your images are about the same shape, and then you just say like I want this crop, and 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 I want this crop. That is basically what you're saying, which is like a patch through a bunch of images. You could do it manually. Actually, that's how I did this first one. I did this one totally manually because I got different scales. It was like kind of a nightmare to do that by hand.
But then that's more focusing on form than composition. So when the composition is
Correct.
really-
So that's where it gets tricky, right? Is if you want composition, or like, actually, let me just show the original data set for this. This will be really helpful to see.
Yeah.
Also, this is a 3 terabyte hard drive, and this is all my machine learning work. So, welcome to hell.
Can I use an external hard drive?
Yeah, this uses an external because that's like a nightmare otherwise. So I want, let me see, what do I want? I want this thing. So all the raw images here, those are not the correct raw images. These are the correct ones. So this is what these images originally look like. So the thing is, I only have, well, I have one, I've got like maybe 400 here total. So it's actually gonna be really hard for me to create a data set for StyleGAN that is just these 400 images. I can flip them. I can do some other like techniques, but I'm really not going to get to 1,000 images with them.
So you're prioritizing form over composition to have more interesting results.
Yes. So the other thing that's important to know is that you only have 1024 by 1024 pixels. So this is a 2400 by 3200 image. But like when you compress that down to a square, an image that is this complex, like it's really kind of small when you actually look at it. So it's really important to think about the complexity of your images when they get scaled down to that size. Because the other thing to remember about, well, one thing to just know about most of these models is that they generalize in a way that sort of produces fuzzier results. It won't always be fuzzy, but like just think about it as like it is basically fuzzying your data set. So something like this, where like there's a lot of detail I like, is not going to show up in my final model because it just gets compressed. Part of the way that a machine learning model works is it actually compresses your data, then uncompresses it. So when you compress something, it's going to lose it's going to lose some detail. So it's important to think about like this might not be a good image for 1024 by 1024. This would definitely be a bad image for 256 by 256. Like don't do that because it's just going to like get murky. It's going to be muddy. It's going to be pixelated. It's just not going to work. So it is important to think about like not just composition but also scale, other things as well. So there's a ton of like different things to think about. And like the reason I want people to make stuff in this class is like that's the only way you can think about it, right? I can tell you all about these things, but until you do it, you won't realize it. So yeah, so this is the original data set. What was nice is a really high res image, so I could do a bunch of crops out of it. That won't always be the case. The reason that I actually ended up doing those crops is because I wanted more detail than I was getting out of a normal square model. So I did prioritize like. I actually also like the composition of those sort of like crops with like the very viney sort of directions. But yes, I did make that decision consciously to make that crop rather than I want the outside shape of a flower. Yeah.
So you have these 400 like original images, and then you just basically quadrupled your data set by cropping it in different places.
Yes.
Okay. Cool.
The other thing is you could also imagine like a crop that goes here. And a crop that goes here.
And the overlap doesn't really affect.
So think about it this way. What you are telling a model with those crops is like, it is okay to have a flower down here.
Oh, gotcha.
And it is okay to have a flower up here. Like again, if you think about everything as a statistical model, what you are saying with a face, when you flip a face, is that it's okay for an eye to be slightly lower or slightly higher. But it's not okay to have eyes where your mouth are, right? Like, so that's basically what you're telling these models. It is okay to consider this an accurate representation of an image. And it is okay to think about these positions being in these places. Now, if I only had 5 images and I was just constantly cropping around this thing to try to generate 1,000, it's not gonna work. You want some level of diversity that is like beyond just like one image. Is again to the maps question. Like, you would probably want to find different styles of maps, or like it's also like you could do that cropping feature through Google Maps, and all it would spit back is like a fake version of Google Maps. And I don't know if that's actually interesting, right? Or it's like you have to sort of decide what actually is interesting as the output of that.
So for the bird example from a past student, so that all the birds were kind of in a similar spot.
Yes.
Unlike this.
Yep, exactly. And that is a great way to call it out, where it's like she actually wanted to highlight the like stereotypical bird photo, right? So she found all these bird photos where it is like the bird is centered, there's a branch, and then there's background. And like what you get out of that is really interesting, where the bird almost never changes, right? There's slight differences in the textures or like position left or right, but like everything around it goes crazy. I think like that's a really interesting way to think about it too, is like, and that's also why faces work really well, right? Because your basic facial features aren't moving, but like color is changing, or your nose is broadening, or your hair is going long or short.
Mm-hmm.
So what is similar is worth thinking about too, because that means it's going to learn that similarity and probably be almost static. Like you'd almost think about like, could you make a model where it's like you have a silhouette of like a face or a shape, and then everything around it is changing, and then when you actually like generate that model back, it would keep that shape, and everything around it would change, and that's pretty interesting too. One thing I think is really interesting about the StyleGAN model is that you can do this animation. So saying how like it might not make sense to like just train it on the same images over and over again. One thing you could think about with that is like you're actually animating between different models, or you're animating between the steps between those things. There are better ways to do that, or there are other ways to do that might not involve training your own new model, which I'll talk a little bit about next week. But in general, like there might be reasons why you would do something like this in StyleGAN just to get that interpolation capability out of it. Yeah.
You know that game set where it's like different shapes and you have to pair them based on like what the pattern is, or if they're filled in, or what the shape is. Like, is that another way to generate a lot of different?
For sure, depending on it all depends on what you want to make, right? It's like if you have access, or like if you're using a vector data set and you could change the colors or the shapes or like outline filled in, that's the way to think about it. It's just again like what do you like that get like anything with vector gets to the case of like why wouldn't you just like script something to generate those vectors, right? Like it just becomes a like what are you doing and what are you hoping to get out of it, and is that different enough than doing the work yourself? That's generally how I describe it. Like StyleGAN works well with a level of complexity that you yourself could never do, right? Like me to generate a 3D model that could generate all of the interpolations between this thing would be like probably like a 5-year project, right? One, I'm also shit at 3D, but like also just like doing that work would be hard. This is a way to like sort of hack your way through that.
Is it fine to, let's say I'm planning to take still photos myself to train a StyleGAN, is it fine to take a video and then extract the frames?
So glad you asked that. Yes, but you will get a different look for things. So let me actually just show you. I just did that with a video. Where did I put that video? Let me see. It's in here. So I have a bunch of StyleGAN like video types of things. So I don't know if you've ever seen Bruce Connor's Breakaway. It's like a famous like 60s video, like one of the first music videos ever. So I basically trained that and like, so first off, this is a really low resolution video.
Is this the original?
This is not the original. This is what it trained back to me. So again, that blurriness factor, like it's blurring a lot of, yeah, this becomes really creepy and scary. So when it relearns video, it is tricky because what you get back from a video is not what the same as you would get back from different image states. And part of that is because of how these clusters work. So like with video, you actually end up with a bunch of like very, very, very similar images in clusters. And so what it ends up doing is it ends up sort of hopping between states. So like it'll traverse this area a little bit, and then it'll hop over here, and then it'll hop over here. So you get these areas where it's like, it sort of understands like video, and then it like jumps out and does something else. And you get a cool look with that, but it is very different than what you might get with just like different like images of static images in different places.
So this is a StyleGAN that's feeding and exporting the same format more or less? Like you fed
I fed it video frames, and then the output is this other thing where it's just like, again, it also sorts all these frames in ways that you might not expect, right? And that sorting is what is interesting, because you get sort of this nonlinear space where it doesn't really understand time, right? And actually, I talk about this a little bit next week, where it's like next stream prediction understands motion, it understands time very well, but it doesn't understand features. Whereas StyleGAN is the reverse. It understands features really well, but it has no concept of time because everything's been fed in as a static image. So actually there's a video that is looping over here. There's a video, let me see if I can find it really quickly. There's a video of waves. Also like super disorganized here. Waves, yes, so waves. So this was fed a video of just like a beach scene, right? But it has no concept of actually how a wave is supposed to start at the top of the screen and come all the way down and crash and start over. So it's like this like non-linear interpolation of how a wave might work. It's pretty cool, but again, this is what you're gonna get out of something like a video. Whereas other things, it might actually interpolate between different images. Yeah.
And then, so if you are to feed a video into this, then you would kind of need like static video as well, or like, would you
You
feed
you
it
can
like a
feed it more.
movie? The whole
So
movie
okay,
will
so let me see if I have the breakaway video, because I think it's like helpful to sort of see what actually fed it.
Is this a breakaway video, kind of like a steady cam, and then like a person is walking around on the stage?
So all right, this is, let me just jump ahead a little bit here. So this is what it looks like. So there's these images, like it's different cuts of like different depths. So like sometimes the woman is just at this site, sometimes it's really close up of her. Now the problem with something like that is that what it ends up learning is like a really muddy interpolation. So the reason that video is very muddy is because it's trying to generalize this and these close-up videos. So it's trying to understand how they both work together. And it ends up in just sort of like a little bit of a blurred space where it's like trying to figure out how they should both work together. So one of the things that's important both with next stream prediction and with StyleGAN is to think about where cuts are. Next stream prediction especially, cuts are like death to a next stream prediction model. But especially with this, it's like, what scales are you working at? Again, think that like StyleGAN wants to see a diverse set of data, but like not too diverse. So if you've got like a big like zooming in shot, like you're gonna have very different scales of stuff. And it's gonna try to combine those two in a way that it can understand as like a statistical model. There is another advancement where like there's actually a StyleGAN model that has class labels. You can actually say like, this is a zoomed out version, this is a close-up view, this is a mid view or whatever. Sorry, I'm not a videographer, I don't know those actual terms, but like you could label each of those. And the idea is that it would hopefully like actually do this clustering, and it would actually understand things a little better. In reality, it's like just slightly better, or like it is slightly better, but it is good.
And then you can ask it to generate out of a specific cluster.
Yes, yes. The other way to do it is to actually like try to figure out this space and just animate within the space. That's like kind of crazy, but like, you could do